All right, good afternoon, everybody. I hope you're doing well. I'm seeing 1 p.m. on the dot Eastern time, and so we're going to get going here. My name is Zane Heather. I'm the program manager of the National Hurricane Program here at FEMA. It is my honor to welcome you to the second day of K0311, second and final day. I'd like to thank you all for taking the time and space out of your busy schedules to be here with us, the National Hurricane Program team and the National Hurricane Center team. We're going to finish strongly today. We're going to start with Unit 3 on forecast uncertainty delivered by the Hurricane Center. We've got Unit 4 on making better decisions, and then we'll finalize with a quick overview and demo of the HRVAC workspace. And so that's all to say. We've got good stuff coming up for you today. Just some general housekeeping notes at the top here, so that you all have access to all the resources available to you during this meeting. If you need to access the course materials, that is the PowerPoints, as well as the student guide, you can do so. I dropped the links to that in the chat. You'll find that at the National Hurricane Center's webpage under their outreach section. If you click that link or navigate to that page, www.hurricanes.gov is the easiest way to get there. You will see a section that says K0311 Hurricane Readiness for Coastal Communities. You all know that's this course. You can get those presentation materials there. Additionally, if you'd like closed captioning in English or in Spanish, so translated into Spanish, you can do so given the second link I dropped in there for closed captioning services. It's the same link. Just so you all know, if you need English or Spanish, you would go up to the top right of your screen and select that language option. You should see by default, it says English. You can go up there and select Spanish. Just so you all know, these sessions and this training is being recorded and it will be available after the fact. We'll make sure to push that out to attendees. And then last but not least, if you'd like official credit from NDEMU, formerly EMI, so the National and Emergency Management Units or Continuing Education. To register for that, you must go to NDEMU's webpage and register for the course. That information is also in the chat. It is the training.fema.gov link that you see there, and the course code is SL05M. So go and register if you'd like credit. If not, feel free to reach out after the fact with any questions or comments that you have. And one quick note for that, for registration to get credit for this course, you need to attend both days. You need to fill out a NDEMU survey or questionnaire that will be sent to you upon registration. Return that, and then you've got 2 weeks to do that. So you can register, fill out that survey, send it back in the next 2 weeks, excuse me, and you will get course credit for 311. All right, without further ado, you've heard enough from me. You'll hear more from me in Unit 4. It is my pleasure to pass over to the National Hurricane Center for forecast uncertainty, led by John Cangelosi. John, the floor is yours.
Yeah, thanks, Zane. Hi, everybody. As Zane mentioned, I'm John Cangelosi. I'm going to start off Unit 3, but this is really a team effort. Maybe you can see some people behind me. You're going to hear from all of them for this unit, and then we'll pass it back over to FEMA for Unit 4. So by the end of Unit 3, we are hoping that you guys, let me see if I can get this to move. Hang on. Might need technical support here, Larry. There it goes. There you go. All right, but I'll leave it there. By the end of Unit 3, we're hoping you can do these things. Explain how wind speed probability products are used to predict the chance and timing of hazardous winds. Explain uncertainty as it relates to the arrival times for tropical storm force wind speeds. Larry's going to do that. And then Laura's going to talk about surge, and we're hoping you can identify products used to evaluate the storm surge risk and also identify and discuss some coastal surge models. So let's start with uncertainty. So you see a forecast from the Hurricane Center. You know it's not going to be exactly right. What we're hoping to start this off with is to quantify what the uncertainty is generally like. When we're talking about uncertainty, we're talking about these two elements of the forecast process: the track prediction and what the error typically is like, and the intensity forecast and how off we typically are there as well. So let's take you through history for a minute. We've been making track forecasts at the Hurricane Center for a long time, going back actually to the 1950s. But this stat starts in the 1970s, and there's no numbers here, but we just want to give you a sense that the track errors have been going down over the decades, meaning the forecasts have been getting more and more accurate. In the 1970s, you could see where the errors were. They dropped a little bit in the 80s. In the 90s, they dropped some more. That progress continued through the 2000s and 2010s. And although not plotted here, the errors in the 2020s are even lower than that. So certainly today, the Hurricane Center is much more accurate than we were 10, 20, 30 years ago. In fact, If you're interested in statistics, we can point you to some resources. Our errors today are about half the size of what they were about 15 or 20 years ago. So a lot of progress has been made. However, we're still here to talk about uncertainty, because despite the progress, there is still errors. And I think in our lifetimes, everybody, there's going to be errors. There's no way of really pinpointing these predictions down. So we have to deal with that and account for the uncertainty. Here is the average uncertainty. The Hurricane Center's forecasts are typically off by about 35 to 40 miles per day, such that the day one error is around 37 nautical miles. And by the time we get to day 5, it ends up around 200 miles. That is the average error. So typically account for those, draw error bars around the predictions around that size, and you will more or less get to the right place. But if you want to be a little more savvy, you could do a little better than that, because we know there are characteristics of our track forecast performance. So if you look at the whole sample, all types of systems over the entire Atlantic basin, again, the average error is around 35 to 40 miles per day. But if you only look at, let's say, the weak systems, we're talking about tropical depressions or weak tropical storms, believe it or not, it might be counterintuitive, those are more challenging to predict. Our average track errors for those subset of storms is a little bigger, around 40 to 45 miles per day. Conversely, if you look at the storms like hurricanes, especially major hurricanes, they are more predictable in terms of where they're going to go. The average error is lower at about 25 to 30 miles per day. We typically get discussions here, especially when we do this in person, is that we just simply try harder for stronger storms. I promise you that's not it. Weak systems are lopsided, they're asymmetric. If you kind of visualize them, thunderstorms are on one side, there's not much weather on the other side. Those sort of really lopsided systems are much more challenging to predict for us and for a lot of the models as well. All right, let's switch gears. Let's talk about predicting the storm's strength or intensity. This has been a much harder road. If you take a look at the errors in the 70s, it was basically the same in the 80s, basically the same in the 90s, pretty much the same in the 2000s, meaning over that period of time, we were not really making any significant progress in improving our performance for predicting the storm strength. But something's changed in a good way. In the 2010s, the errors have dropped nicely. And again, not plotted here, but we've already looked at this. In the 2020s, the errors are actually accelerating downward, meaning we are starting to get much better at predicting the storm's strength, which is really, really good news. That being said, we still make mistakes. Here's what the average errors look like. The day one error is around 9 miles an hour. And then you can see it goes up to around 15 miles an hour by day 5. I don't want you to get too, in the weeds with the numbers here. Here's a simple way to look at it. We're typically off by about 1 Saffir-Simpson category. So if you're listening to us today from the Gulf Coast or Florida or the Southeast Coast, you may have heard this old expression, hey, prepare for 1 category higher. You know where that came from? That came from factoring in these average errors. And I think that statement still holds water today. However, if you're in the mid-Atlantic or the Northeast, I don't think you should do that. You're probably going to over-prepare and over-warn, because typically as storms make their way up to your latitude, they're usually weakening. And this 1 Saffir-Simpson category is really not good to factor into your planning tool there. All right, now, some of you might have heard this term before, rapid intensification. We sometimes abbreviate it and call it RI. Now, it's not just something we throw out there. It actually has a formal definition. Rapid intensification is defined as an increase in the storm's winds by at least 35 miles an hour within 1 day. So in order for the storm to be classified as rapidly intensifying, it needs to meet that definition. So this is really 2 decades. I can tell you, I hate when storms rapidly intensify. I mean, especially, we can't always see it coming. But I can tell you some good news. We have made a ton of progress over the years. When we look back at how we predict rapid intensifiers back in like 2010, 2012, as compared to what we do today, the errors for this subset of storms have been cut in half. That being said, it's still a challenge and it's still a work in progress. Let me take you through a specific example. This is for Hurricane Iota back in 2020. And we were on the forecast floor. Initially, the storm was a tropical storm. storm had 65-mile-an-hour winds, and our 24-hour forecast predicted 105-mile-an-hour winds. So you can see that was a really strong ramp up in wind speed in just one day by about 40 miles an hour. Again, classifies as rapid intensification. And if you look at the curve there on the right, you'll see that blue line's our prediction, the white line's what happened, and at 24 hours, it was a perfect forecast. Looks amazing, right? Well, there's a bad side to this. Take a look at the blue line. By 36 hours in the future, we thought it would get stronger, but not nearly strong enough. We predicted 120 miles an hour. It ended up at 155 miles an hour, leaving us with a very substantial 35-mile-an-hour error. So again, a work in progress. But predicting that exact evolution, the magnitude, the timing of this is nearly impossible still. But as I mentioned a couple of times, we are getting better at this. All right, so this is where we segue now, and Larry and I are gonna really kind of talk about wind speed probabilities. Now, I wish you were in front of me. I hate doing this stuff virtually. It's so hard to interact, but I just want you to kind of visualize something for me. How many of you, and you can be honest with yourselves, no one's judging you for it. How many of you look at this and quickly zoom in on those dots, those forecast points, or the line, and make judgments about what you might do in that situation? If you do that, that's okay. A lot of people do. But that is definitely not the right thing to do. And really, for the next 20 minutes, Larry and I are going to talk to you about a better methodology to really calculate your specific risk for wind. So this case is for Hurricane Charlie. Now, if anybody's listening to us from the Tampa area, even though this case is 2 decades old or so, a little more than 2 decades, you probably remember that Charlie didn't hit Tampa, even though it was predicted to. Here's what exactly happened with Charlie. You can watch this animation. It was headed toward Tampa, and then at the last minute, just deviated a little to the right and made landfall as a Category 4 hurricane in Punta Gorda, Port Charlotte area, I don't know, 70, 80 miles south of Tampa. A lot like what happened in Ian more recently in 2022. And since Charlie was so small, Tampa was just largely spared and really didn't get much overall. So the question is, how do we calculate this risk? Because if you go back here and you look at the forecast, take a look, you can see the orange dots is what actually happened compared to the black dots, the prediction. You'll notice that it wasn't a terrible forecast. It went a little right of the prediction, but it stayed in the red shading area. That's the hurricane warning area, but still kind of felt like it caught people off guard. And back in 2022, it felt like the same thing again during Ian. So let's have a little conversation of how we can do better together and how we can calculate and communicate risk related to wind damage. So that's what we're going to do here with wind speed probabilities. So when we're talking about these alternate scenarios, it all comes down to calculating that risk. So we'll do that together. Now, first, I got to give a disclaimer. The products, especially the text products, are kind of hard to look at. You know, they're going to be a matrix. We're going to walk you through it. I know there's better ways to view this in HRVAC or whatever HRVAC's called today. So, you know, feel free to get the information any way that's most accessible and friendly to you. But for today's purposes, we're going to show you how to get it from our website, and we're going to walk you through it. So there's a text component that we're going to walk you through on the left, and then we'll take you through some of the graphics. And again, Larry will talk about the timing graphics coming up in just a little bit. But first, let's start with a poll question. And the poll question we have here, by the way, for any of you perfectionists out there, that's not me, but if you're a perfectionist, I got to put out a disclaimer first. You can't calculate this. This is only by feel. All right, so with that said, here's the question. The chance of hurricane force winds occurring at Pensacola, if you're not familiar with the Florida Panhandle, is that red dot, during the next 5 days is between which probability range? So it looks like the votes are coming in. They look pretty evenly distributed right now. Actually, really so. All right, we're going to let these come in a little while. And right now it looks like C's in the lead, so there's 20 to 30% chance, and D's pretty close as well, but pretty even distribution overall. Again, this is only by feel. We're going to reveal the answer coming up in about 10 minutes, so we're going to make you bust a little bit. All right, so it looks like we got most of the votes in, so I'm going to go forward. So hang on, we're going to reveal the answer in just a bit. So let's talk about how these probabilities work. Here's how they're created. So when you look at them, we're telling you basically how this works. What we do is we create 1,000 realistic alternate scenarios around the official NHC forecast that is coming out every 6 hours. This technique that we use incorporates the historical track and intensity errors, or the things I just talked to you about, meaning the average track errors, the average intensity errors, and to some degree, some size information. Now, the technique also knows where land is. So if you look at that animation on the right, you'll see that the colors change from red and purple to yellow and green. That just means it's weakening over land, and that's important. And to some degree, it knows about track model spread. So when the models are all over the place and you can see them diverge, these solutions span out a little bit. And when the models are tightly clustered, these solutions zone in some. So hopefully that all makes some sense. So let's show you how to use it. Let's say the only city you care about is Atlantic City, New Jersey. I spent a fair amount of time there. All right, so for this particular circumstance, you can see the solutions ran out. You're looking at the star, which is where Atlantic City is located, and 100 of these 1,000 scenarios produce hurricane force winds at Atlantic City. So just simple math here, 100 divided by 1,000 is 10%. And the way you should interpret that is Atlantic City has a 10% chance of seeing hurricane force winds. But side note, what do you do with that information? What does 10% really mean? Let me ask you, if someone said, hey, there's a 10% chance of rain today, you heard it on TV, or your local National Weather Service said 10% chance of rain, do you do anything? I mean, I'm a meteorologist and I don't, because the way I look at it is, well, that's probably meaning it's not going to rain. And again, what's the consequence? The consequence, if you're wrong, is you don't take your umbrella, is, well, you get wet. Big deal. Conversely, what if we told you there's a 10% chance that you're going to get hit by a car when you cross the street? Do you think you'd look both ways? I'm pretty sure. Or I typically say when there's a class here in Miami, what if there's a 10% chance that you're going to get food poisoning if you go out to eat tonight? You think you might cook at home, for example? The point is, you can't separate the probability from the consequence. And the 10% chance of hurricane force winds is kind of a big deal. That's compared to the 10% chance of just seeing some rain. All right, let's walk you through the text products now. So if you go to our website during any particular hurricane event or tropical storm event, and you click wind speed probabilities, the text product, it's going to look something like this. Now, let's just say for simplicity, we're going to pick one place. There's going to be a list of cities, but let's just pick on Tallahassee since it's right there at the top of the list here. First thing you might notice is, why are there 3 rows for Tallahassee? Well, there's a reason. They're different wind thresholds. So you can see the first row is for tropical storm force winds, labeled 34 knots. The second row is 50 knot winds, or 58 miles an hour. That's typically where sustained winds become really damaging. And then the third row is hurricane force winds, or 64 knots. So that's what the rows are. They're just different wind thresholds. But now there's information on the columns that we got to walk you through. So there's 2 numbers. There's a number outside the parentheses and a number inside the parentheses. The number outside of the parentheses represents timing information. If you look above the number right here, for example, if you can see my cursor, this X depicts that there is no chance of tropical storm force winds starting within the next 12 hours. And likewise, there is still no chance of tropical storm force winds beginning between 12 and 24 hours. But then there's a 1% shot between 24 and 36 hours. And then after that, you can see the probabilities really ramp up. Now, the number inside the parentheses represents the cumulative probabilities. And you can see they just add up. So the 1% here is then in parentheses, and then 6 goes to 7, and then so on and so forth. And the way you can interpret this is Tallahassee has a cumulative 81% chance of seeing tropical storm force winds and 24% chance of seeing hurricane force winds sometime within the next 5 days. So hopefully that makes some sense. Now, if you don't want to read numbers, the good news is you don't have to. You can look at the probabilities through the graphics. The only thing is you can't get timing information from this graphic, but you can get timing information from the one Larry is about to show you coming up. So the 5-day cumulative graphics are available for the same wind thresholds. Tropical storm force winds here, 50 knots or 58 miles per hour here, and hurricane force winds that are displayed here. And the cool thing is you can map these together, and you can probably do this with various software systems, but you can do it on our website too. You can see how the numbers are being plotted there on the graphic. So there's a 38% chance, for example, at Panama City, this is for hurricane force winds, and 9% chance further west, 8% chance further east, and so on and so forth. So can we at least acknowledge that this is better than looking at the skinny black line? All right, we're going to continue if you don't buy into that just yet. So let's go back to the Charlie example, right? It deviated a little to the right. Would these wind speed probabilities have helped if you used them, or during Ian, for example? Well, let's look at what the forecast actually showed. And I'm not sure it existed in 2004, but they exist now. So in this same scenario, Tampa and Port Charlotte in the Punta Gorda area in Southwest Florida both have around a 30% chance of seeing hurricane force winds. They all have about an equal shot. So even though the dot was in the Tampa area, the way you should really interpret this is they all have about equal risk. So if you live in Southwest Florida or West Central Florida, you're all under the gun for a pretty decent shot of seeing hurricane force conditions. And that's really what we want you to get from these probabilities. Okay, and in the end, and I think I'm almost done before passing it to Larry, here's the best way to use them. We want you to look at the trends. Because what do the numbers really mean out of context? But what we want you to get is your risk going up or down? So here's how it works. We're going to pull an example from Matthew in 2016. And for this exercise, the only city you care about is Daytona Beach. So you can see the cone graphic for Matthew. This is advisory number 12. The 5-day error cone at this time was just about to the latitude of Daytona. But when you look at the dots, you'll notice that based on the forecast that we put together, the best shot is this passes to the east of Florida. All right, hang on to that thought. At this point, there's only a 9% chance of tropical storm force winds at Daytona, and there's no chance of hurricane force winds for now. All right, advisory 18, the 5-day forecast point has now reached the latitude of Daytona Beach. You're right at the edge of the cone. Probabilities of tropical storm force winds are up to 15%, still no chance of hurricane force winds. Here's where it gets bad. Advisory 24, pretty big shift to the left has occurred now from NHC. From experience, these paralleling tracks are a pain. And this does happen, just like that Tampa example for Charlie and Ian. Same thing on the other coast. The 4-day forecast point is now just east of Daytona. The probabilities have shot up. 57% chance of tropical storm force winds, 11% chance of hurricane force winds. All right, advisory 28. Now the track has shifted even farther west. A hurricane watch is issued and the probabilities are up. 76% chance of tropical storm force winds, 23% chance, about 1 in 4 of hurricane force winds. All right, advisory 30. Hurricane warning is now in effect for Daytona. This thing may go right overhead. 84% chance of tropical storm force winds and a 28% chance of hurricane force winds. And lastly, advisory 35. Now it looks like it's going to pass basically over or very near Daytona Beach in about 24 hours from now, virtually certain that there's going to be impacts and almost 70% shot of hurricane force winds. Now, in this case, there's an old expression, right? The trend is your friend. You might look at it differently in this circumstance for Daytona, but the point is, it's giving you information and letting you know that your risk is going up. And it helps you quantify that risk rather than trying to chase different models and chase the dots on the cone graphic. I hope this is constructive. All right, let's go back to that question. All right, now, do we do the poll again or did I just reveal the answer?
No, the poll again, I think.
All right, let's do the poll again, if we could. All right, looks like it's been launched. All right, back to the same question. Again, Pensacola, Florida. The chance of hurricane force winds occurring at Pensacola during the next 5 days is between what? Let's see if we can get it over there. All right, we're going to try to launch it. All right, looks like it's moving now. All right, let's see if anything changed, Larry. Did you keep an eye on like what the probabilities were, like what the breakdown was earlier?
Mainly C and D.
I saw C and D as well. It looks like we're sticking with that theme here.
So what did they learn from you, John?
Looks like nothing. We'll see if that influences the rest of the vote. So we got about 300 or so votes in. C still in the lead, 32%. In fact, I think E went up 40 to 50% from what I saw last time. All right, I think that's enough. Let's, is the answer if I click? Did we get the answer? Or do we have to hit?
No, you don't have the answer. You just gotta tell them.
All right, well, congratulations to the minority. 13% of you got this right, which means the answer is A, 1 to 10%. So again, these probabilities are going to look low. The reality is, I think this case was Isaac, from what I remember, and they did not get hurricane conditions in Pensacola. Far out 4 days in advance, there's quite a bit of uncertainty historically. So the probabilities are going to look low, and they're going to increase as we get closer into the event. So again, this is, I know, a communication breakdown. Remember, this is a point probability, not a region probability. So you're going to have to get used to dealing with low numbers. Hopefully this is constructive, everybody. If there's any questions for me, I'd be happy to take it in the chat. And the only other plug I wanted to give is, a lot of what I shared here is going to be in a very short Instagram reel next week. So about a minute is going to kind of summarize a little bit of this. So hopefully that's constructive for you all as well. So with that, I'm gonna pass it over to you, Larry.
Yep. All right. So good afternoon, everyone. Larry Kelly. Spoke yesterday in Unit 1 about hurricane hazards, but you get me again for another day. So let me go back to the slides of the poll. So we're going to build on what John discussed with the wind speed probabilities, and how can we use those probabilities in that model to depict some kind of wind timing, and what kind of goes into that wind timing that we give, and really comes in two flavors: the most likely and the earliest reasonable. Main factor, obviously, going into when is the wind's going to arrive, is the forward speed, the track of the system. How fast is it moving? Is it moving? Is it slowing down as it approaches the coast? And what's that direction of motion? John showed many examples of storms paralleling the coast. If the storm makes landfall in Tampa versus where it did in Punta Gorda, that rightward shift is going to accelerate that timing impact to that given location. And it really is relative to that center where it does cross land. Another thing to think about is storm size. As these systems tend to move north, especially those systems that move up the eastern seaboard, they usually grow in size. So how far out will those tropical storm force winds extend from the center? There's cases where the cone may not even be touching you, but we have such a large system that we are going to see impacts from tropical storm force winds. And really, the storm size is something that's really difficult to forecast and really kind of explain. There's a perfect example that I'm going to show you in a little bit, how these time of arrival graphics are designed to account for some of this uncertainty. But there are some caveats that we'll go through here as well. So just an example, this is Hurricane Irma. I believe it was a Category 5 here at the time. That's the current winds, wind radii of tropical storm force winds. So if you're in Florida and you're planning for something like this, you don't really want to plan for what the storm is doing now, because if those in Florida remember, Hurricane Irma after this time got much, much larger. You can see those tropical storm force winds, hurricane force winds, even strong tropical storm force winds encompass the entire state. So if you were just looking at the forecast track moving up the western side of the peninsula, and not thinking that you'd have to worry about it in northeast Florida or even Georgia, you would be wrongly mistaken. So we do have to count how is the storm going to grow within the forecast period too. And just going back to show you what it looked like 3 days prior to that point, it's about an 83% increase in storm size. So another thing that you need to take into account, that storms aren't static and keep that same wind radii throughout the entire forecast period. We have to take into account that these storms usually do grow, especially as they move further north. Back to kind of showing how do we generate these time of arrival graphics. It's all using that same wind speed probability model. It's those 1,000 realistic scenarios that is based off of some of our historical errors, our forecast. Some of the scenarios take the system and weaken it over land, and it accounts for this track model spread. It's really a better way to determine impacts using those probabilities. And from this model, we can then indicate when those winds will arrive using these 1,000 realistic scenarios, and how many of those scenarios bring winds, say, 50% of the time to a certain location, or 90% of the time to be prepared for the earliest reasonable. So we'll start with the earliest reasonable. This is, I don't have any risk here. I need to be everything completed. The 10% chance of onset, it's the most conservative. So if you prepare by the time that's depicted here on the right, those lines, say for the Florida Big Bend area, if I have everything completed by Tuesday at 8 p.m., there's only a 10% chance that winds will arrive before that time. So if you really you have no risk and you need everything to be done or things moved out of the way in your local community, you really should be using the earliest reasonable time of arrival just to make sure you're not caught off guard and your risk is pretty low for anything to happen. And then we also color fill it. So you kind of get a combination of what John was talking about, the wind speed probability. So you get the percentage, for the Big Bend area, I'll just stay there, 70 to 90% in Florida. So you have 70 to 90% chance of tropical storm force winds. And when's the earliest time I could see those? 8 p.m. On Tuesday. So you need completion of preparations be done by that time. But say you want to see, what's the most likely scenario for my particular area? This is the even chance. So that means, out of those 1,000 on scenarios, 500 of them happen before this time, 500 happen after this time. And you can see how that time has changed. Just focus on the Big Bend area. And it's now 8 a.m. So you're talking about a difference of about 12 hours in timing. So if you have a little more, you're willing to take a little more risk and you play that 50-50 game, you're prepared to do something, say Wednesday, 8 a.m., but you are taking in an account that, there's a 50% chance that those winds could arrive before then. And like I said, it's also color filled with that wind speed probability that John talks about. So it's really a combination graphic where you can get, the probabilities for your particular area, but then also some sort of timing. And it's up to you to determine whether, you have a 50% chance risk that you're willing to deal with, or if you don't have any risk, that, use the earliest reasonable timing, and, 9 times out of 10, you'll be okay and not caught off guard with winds arriving earlier than depicted. And how do we kind of do this? It's kind of similar, using an example here from Google Maps. We all check the traffic, especially if you live down here in Miami or another big city. And it's kind of similar what Google does. Say, we're at the Hurricane Center and I have, a dinner on South Beach and I need to be there by 5 p.m. And when you put that into Google Maps, you get this range of timing, right? I can make it there if there's no traffic in 35 minutes, but we're going to account for, up to an hour of traffic. So most likely wiggle room, I could probably get there and I can afford to be a little late if my dinner reservation or something on South Beach. So I can afford to leave, say, maybe in 20, 25 minutes. But if I don't have any, I have to be at South Beach by 5 p.m. or I lose everything. I lose my deposit for my very expensive dinner. I need to leave by 4:10 because I need to get to the beach in that time. I don't have any risk. So I have about a 24-minute window to leave to get to the beach. And just another similar example, Richmond to DC traffic. Do I have any kind of wiggle room? And, say I need to be there absolutely by 5 p.m. because I have a meeting with executives at FEMA. I can't be later than 5. Or, it's not that important of a meeting. I'll leave a little wiggle room. There's a little traffic in DC. I can be a little late. I need to leave at this certain time. So kind of using everyday example of Google Maps, I can't take any risk, or I have a little bit of wiggle room, really depicts that earliest reasonable time I need to leave, or most likely time I can get there a little late if there is some traffic. It's kind of the same way we use the most likely and earliest reasonable time of arrival graphics. So just an example for Tallahassee, for earliest reasonable, there's a 10% chance of exceeding. So there's only a 10% chance that tropical storm force winds will arrive before this time on 8 p.m. Tuesday. And then for the most likely arrival time, 50% chance equally before or after 8 a.m. So there is that range of 12 hours difference between the earliest reasonable and most likely. However, there are some limitations with this. And like I said, Storm size, whether it's unusually large or small, may not be handled well, especially beyond 24 to 36 hours, particularly if a storm is actually growing in size, or if that system is beginning to stall, slow as it approaches the coast. This can often impact the early onset times and compared to what's officially in the forecast. And we're going to go through examples here of a system that performed well, someone that the most likely was a little early, et cetera. So here's an example of Hurricane Michael. I'm going to show you this similar chart for the three systems. So the red is always going to be the earliest reasonable time of arrival. Basically, you have no risk. You need to complete your preparations by this time. The green is going to be your most likely, so a 50-50 shot of whether tropical storm force winds will be impacting your area at that time and how it moves through each advisory. And then the deterministic is that black line, so that's the official forecast. And then the black horizontal line is actually when, for this example, Panama City experienced tropical storm force winds. So you can see, just looking at the most likely, this is an example where the most likely actually fared out pretty well. It hovers up and down for the most part for that horizontal black line. And for the most part, if you would have worked with the most likely, you would have got there right about time. So most likely came in around that 3 a.m. mark for even 0 to 24 to 72 hours. It hovered, an hour here or there around that time. The earliest reasonable always was early enough to where there was no risk. It never was later than that 3 a.m. Time frame, where the deterministic was a little more later in the 2 to 3 day forecast period. But once we got in between about a day and a half, it really did begin to hone in on that earlier time frame. So this is an example where the most likely actually worked out well. But if you had no risk, the earliest reasonable was the way to go. For an example, for a storm like Dorian, if you don't remember, Dorian began to stall and slow down when it was in the Bahamas. So when we take these 1,000 scenarios and we run them, there's going to be some of those scenarios that actually have Dorian moving when it wasn't actually moving at the time. Just the way that the 1,000 models are run. So this is an example of where if you would use the most likely time of arrival, you were okay in about 2 to 3 day time frame. But then the 0 to 24 hour time frame was way too late. If you would have been using that, you would have been caught off guard because the winds actually arrived at 4 a.m. But even a day prior, you said you had another 6 to 8 hours if you were using that most likely time of arrival. Or once again, if you would have been using the earliest reasonable from the beginning, you would have never been caught off guard because the earliest reasonable was always early enough before those tropical storm force winds were there. So Hurricane Dorian, a slow storm. This is where, if you see a system beginning slow or it's forecast to slow or stall, maybe you need to start adjusting your thinking to maybe I should be using that earliest reasonable time of arrival graphic. And another one for Hurricane Nate as well, another system that began to slow. You can see here that the most likely was often too far in the future for the entire really 3 day period for every advisory. It was always a little early. It didn't begin to get closer to the actual time until about 24 to 36 hours before using the earliest reasonable. While it was closer to that 6 p.m. time frame in the afternoon, it always did keep you prepared early enough for those tropical storm force winds. So it's just an example of, every storm is different. It's really about risk calculation to your community, what you need to use. If you have absolutely no tolerance, no risk, please use the earliest reasonable time of arrival, and then most likely. But always, evaluate the storm as well. And what is the hurricane saying? Are they expecting a slowdown? And that can cause some of these issues with the most likely time of arrival graphic. So in summary, from John's and my presentation, NHC's forecasts are improving, but the errors remain, and we're very open about them, and we want you to know about those errors. Forecast of basically off of by a category is what you should be planning higher, and some of those track errors. And the error cone is not the cure for the skinny black line. We really want you to look at those wind speed probabilities And some of the examples we showed show that, especially for Charlie, if you were in Tampa and in Punta Gorda and you had a 30% chance of hurricane force winds, you should be taking the same preparations in each of those cities, not just following their error cone. And how we use the wind speed probabilities to derive the timing of those wind hazards and some of the caveats to be aware of, especially with storms increasing in size and the slowing motion. And that's some of the assessment we gave you there with those last few examples. So we're just going to revisit the topics because we're going to kind of flip here from how the wind speed probabilities and time of arrival graphics are used. And we're going to talk about storm surge risk and coastal surge modeling with storm surge specialist Laura Alaka.
Awesome. All right. Hey, everybody. My name is Laura. I'm a storm surge specialist here at the National Hurricane Center. I'm excited to kind of take over the rest of this presentation. So the first couple points listed on this unit objective slides is going to be things that you've already learned about from John and Larry. And so now we're going to switch to that storm surge aspect. We're going to identify products that are used to evaluate storm surge risk. And so I know there could be hundreds of people on this call that have never seen this storm surge information. So I'm going to do my best to walk slowly through these slides because I know you can't stop me and wave your hands and say, I don't understand. So I've also got Cassie Mora here. She is a storm surge specialist here as well, and she is on the Q&A. So feel free to drop anything in there that you have a question about. And so aside from assessing our risk, we're going to be able to identify and discuss coastal surge models, and potentially that is good dinner conversation for everybody. All right, so we will get started here with Hurricane Sally. We're going to start with an example storm. This was from 2020, so an actual storm surge event. This is going to loop a few times, and I'm going to try and explain everything you're seeing on this image first. So you can see the colored contours, the red, yellow, blue are that initial wind swath. The line with the squares on it is the actual track of Hurricane Sally. And then you can see the forecast cone. And so this loop starts about 48 hours prior to landfall. And we didn't show that skinny black line by design. So you do have the option to show your partners and your end users the cone without that skinny black line so that there isn't that focus on it. I think that was a question in the chat. But here you see that the forecast is pretty good, but you'll notice that the actual track of the storm did track along the edge of that cone. And so how does that impact, the actual impacts of storm surge? So here with Hurricane Sally, I'm going to go to the next slide. About 24 hours prior to it making landfall, the forecast, that skinny black line, not thinking about the cone, but that line in the middle of the cone was forecast to make landfall just west of Mobile Bay. And so you can see here that Sally was forecast to make landfall right here west of the bay. This circle represents the RMW. That is the radius of maximum winds where you expect the strongest winds to be making landfall. And you can see with that landfall location just to the west of the bay, those strongest winds are pushing water right into Mobile Bay. And so here, the colors represent the storm surge flooding footprint. And so the yellow represents greater than 3 feet, orange represents greater than 6 feet, and 9 represents greater, or red represents greater than 9 feet. And so with this single solution, what do you think the people in Mobile Bay are doing? They've got a really high storm surge risk from this single outcome, and so they're preparing. But what about over in Pensacola? Over here it's suggesting, we see some blues greater than 1 feet, maybe some minor flooding greater than 3 feet, but you see the limited risk here in Pensacola. So the deterministic slosh shows that there's limited surge threat in Pensacola. And when I say deterministic, I'm talking about that single skinny black line. If I were to just run this single track through my model, this is the result I get. And so with this forecast, we're not really saying that Pensacola has much of a threat. But when in reality, 24 hours later, the storm makes landfall, it actually makes landfall east of Mobile Bay. And so again, that very small shift in track has a huge difference on the flooding footprint. You learned about all the factors that influence the amount of storm surge a particular place is going to get from Heather yesterday. And so now we're seeing that small track shift made a huge difference. In addition to that track shift, the RMW, that size of the radius of maximum winds, increased slightly. And so in reality, the storm made landfall here near Gulf Shores. And you can see the radius of maximum wind is pushing the strongest winds into Pensacola. So we see the highest water levels located there. And then what actually happened in Mobile? Well, in reality, you have that very strong offshore flow. You can see the eye of the storm is pushing water out of Mobile Bay. And so they may have actually seen water levels. They definitely did see water levels below normal. And so just that small shift within 24 hours makes a huge difference in the actual outcome and the impacts of the storm. So how are we going to prepare for something like this? That's what we're going to discuss here today. And the first thing I wanted to tell you about was our tool. I kind of hinted about it in the last slide, but we have a storm surge model that we run here at the Hurricane Center and the National Weather Service, and it's called the SLOSH model. It stands for the Sea, Lake, and Overland Surges from Hurricanes model. It's a numerical model that is used to estimate the storm surge heights for historical, hypothetical, or predicted hurricanes. So it's it can do it all. And so it is our workhorse, and we run it not just one time, but we run it lots of times. And the reason that we like SLOSH is that it is computationally efficient. So it is a numerical model. It's going to be solving the equations of the ocean, and if we apply a wind field to it. But the great thing about it is that it is extremely efficient. And one reason that it's efficient is because that we run the model in these basins. So you can see these kind of shapes along the coastline, and they're broken up into different regions. So when a storm threatens in the Gulf of Mexico, we only have to run the basins that are in that location of interest. And so we save computational efficiency or computer time by running this efficient model only where it's needed. So we don't need to waste our computer resources running things in the Northeast when we know that the threat is in the Gulf. So this is our model. It's a great tool, like we said, for hypothetical or predicted storms. And so we use it across a range of applications. And so those are the tools that I'm going to be discussing through this PowerPoint. So this is kind of starting to get our feet wet into the risk tools that we offer here at the Hurricane Center. Over here, we have the black and the gold. These are our risk maps. You'll notice on the bottom, we have this arrow, and these black and gold tools represent the kind of planning and more forecast uncertainty phase of the timeline. And so these risk maps have pretty silly names. They're called the MOMs, the maximum of the meows, and the meows, which are the maximum envelopes of water. So MOMs and meows are what we call our risk maps. And these are extremely helpful tools. They're pre-computed, available now, and ready for end users to start planning and preparing for hurricane season. And so obviously these are used for planning when we have more forecast uncertainty. And so you'll notice on the bottom, the arrow represents kind of that planning phase. As we move to the right, we're getting into the more forecast certainty phase. Sometimes meows can be helpful kind of when we're starting to peel back the layers. But once we get into the real-time products, we're within 72 to 48 hours prior to impacts. Then we're going to start to have our real-time products. And so I'm going to discuss all of these products today. This is the probabilistic storm surge, or what we call our P-surge model. We have the potential storm surge flooding map, which comes out of P-surge. We have our storm surge watch warning, which I know was discussed yesterday, as well as the peak storm surge forecast graphic, which was also discussed yesterday. So we kind of have to go through this phase of understanding and planning, and then we have some additional tools that you can use in real time. So with that, I'm going to discuss the risk maps first. So these are the moms and the meows. So I'm going to start with the meows because they're kind of the building block for the moms. And this is our introductory slide to them. It gives you the definition. Meows are essentially a composite of the maximum storm surge for a given set of parameters by basin. So they're going to be computed in those basins that we saw on the slosh model description slide. And the parameters you can see are listed on the bottom here. So these parameters are user selected. So the great thing is you can go in and customize and pick the meow of interest. And so on the bottom, you'll see that the user selections for the meows are the SS category, or the Saffir-Simpson scale. And so that's category 1 to 5, showing the intensity of the storm. The user can also select the forward speed, how quickly that storm is moving towards the coast, as well as the storm direction. It's kind of a compass direction giving you the trajectory of the storm. So these are all customizable, and you can select the parameters as needed. There are a couple things that are built into the meows. We are going to assume high tide anomaly, especially in the planning phase. We are not sure when the storm is going to make landfall relative to the tidal cycle. So it's always good in planning phase to plan for high tide. The size of the storm is also built into these meows. We know that the storm size can modulate how much water a storm can push. So we do account for larger storms in the meows. And you'll see that the landfall location is also perturbed in the meows, and so you won't need to worry about landfall location. And again, these are used as guidance for planning and operations. So this is kind of your summary slide. If you don't understand it yet, I'm going to build one for you, and hopefully that will kind of answer your questions on what exactly it is. So let's build a meow. So here you can see this is the South Carolina and North Carolina coastline. This shape represents the slosh basin located in this area. Along the bottom, you see a skinny black line. That is your single track. And it's going to have these user selected parameters. It will be category 3 with a landfall direction of west-northwest, a forward speed of 15 miles per hour, and we're going to assume high tide. And so from this one single track with these user selected parameters, this is the slosh result that you get if you were going to run the model just one single time with this track. And we're going to be following along with this one single pixel located in North Carolina. And you can see that from this one single track, you have a storm surge risk of 4.8 feet at that one single location. Okay, so that's just one track. We're going to build out the meow now. So if I were to just take that track and move it slightly up the coast, you'll see that the flooding footprint changes, and my risk at that single point in North Carolina has gone up to 5.3 feet. And so you'll notice that as you add tracks here, the flooding footprint is going to change from each individual track. And so you'll see that the highest storm surge occurs in that area of strongest onshore winds in that RMW, or radius of maximum wind. So you can imagine that the winds are circulating this way, bringing the highest water right in that eye of the storm. And then the water kind of trails off away from that. But you also get dangerous water levels well away from the eye. So if you're just going to continue to add tracks here to build your meow, you'll see that There is a sharp gradient on the other side of the storm where you have that offshore flow. Remember, water goes where the wind pushes it. And so if you were to just continue that all the way up the coastline, and then I'm going to retain the maximum water level from any one of those simulations, and that gives me this result. And you'll notice that one single point we were following along the North Carolina coast has the meow is 13.8 feet. So I don't know exactly which one of these tracks produced 13.8 feet, but one of them did. And that's showing that everywhere along the coastline, your vulnerability to these user-selected parameters. Again, you could probably guess which track actually caused this. It might be one of these just south of it where you expected the RMW, or the radius of maximum wind, to push the water into that area. But we aren't really concerned with exactly which one of those tracks. But if you had a storm threatening your area, and you knew it had these types of parameters, you could plan for this height. And the great thing about the meows is that, these are very specific user-selected parameters. You can imagine there's a really large catalog of meows that you can choose from. All the different landfall directions, all the different forward speeds, and different categories. So it's a really great tool set that you could kind of take a look at your vulnerability. And the great thing about it is these products are available right now in the HURAVAC tool. And so all this information is there for you to start planning now. So that's the meow. And so I started with the meow because it is the building block for the mom. So now that you've imagined how many meows there are, the moms are just the maximums of the meows. And so it's actually the worst case for a particular storm category. So you can imagine now there's only a couple of these moms because they are by category. And so there are going to be a combination of many scenarios. They're going to include that forward speed, all the different angles of approach, that size is built in, and the initial tide. So this is kind of your worst case for a particular storm category. And remember, no single hurricane is going to produce the regional flooding depicted in these because they are composites. Remember, in the last one, we retained the maximum pixel from any one of those tracks. So we're going to do the same thing in the moms. So now that we've built the meow and introduced the mom, let's build the mom. So this is the meow we built before. This had the west-northwest trajectory. It was moving 15 miles per hour and category 3. And so you can imagine that we have meows for all the different directions. So let's change that direction just slightly. We'll choose northwest. Again, we'll follow that single pixel along the North Carolina coast. And you can see that the vulnerability increases from this direction. We'll change the direction again. This is north-northwest, moving north, moving northeast, all the way around the compass. And then we retain the maximum pixel, or the maximum storm surge at every given point. And this is your vulnerability to a category 3, moving in any direction at any forward speed, but at category 3 intensity. And you'll notice that our vulnerability at that single point is 14.7 feet. So the meow we looked at was not too much different than what you see now, but there are areas on the map that had different vulnerability to those different meows. And so this is the mom. It is your category 3 mom. So that finishes up the risk maps. And so I'm going to move on to the real-time products. Hopefully that makes sense. The great thing about the risk maps is, again, they're in the HURAVAC tool. The moms are also on the hurricanes.gov website, so you can find them on our website to just get that understanding of your vulnerability for planning. The moms are really that tool used to design the evacuation zones. And so we really encourage everyone to kind of dig into that data, overlay it on your assets, and start that planning process now. So with that, I will move on to the real-time products. And so I'm going to start with the probabilistic storm surge model. And so P-surge is essentially just an ensemble version of our slosh model. So we're going to run our slosh with a family of storms, not just one time. And so that is what we're going to call P-surge. And P-surge is going to be based on the NHC official forecast. And the uncertainties are based on the historical errors of that. John went into a lot of detail about all of their errors, and we have a full understanding of that. And that is how that family of storms gets built out, because of our understanding of the errors. And so you'll notice here, this is an example from Hurricane Laura. At the very center of the P-surge ensemble is the official forecast, this dashed line. And you can see that we have alternative, that family of storm tracks as gray lines here. So we're varying the landfall location. So you'll see it takes into account uncertainty in the track or the landfall location. Also, we have uncertainty related to forward speed, because how quickly the storm is moving towards the coast is going to impact how far inland the water could penetrate, as well as it will change how the storm makes landfall relative to the tidal cycle. So that needs to be taken into account. We also vary the storm size. We know that larger storms can push more water towards the coast, as well as the intensity. We have weaker and stronger members to account for changes in intensity. So the great thing about slosh and P-surge is that it does account for tide. And so we are able to capture that in the results. And it's going to provide the storm surge heights above ground level, which is our main method of communicating storm surge forecasts, is above ground level. All right, so this is another just animation or visualization of how the P-surge ensemble is perturbed. This is a case from Hurricane Irene, and so you can see at the very center of the ensemble is the skinny black line. But about the skinny black line, we have alternative track scenarios. And so this particular P-surge run is going to contain realizations that make landfall all the way in South Carolina, as well as landfall or tracks that don't even make landfall. And so all those different solutions are taken into account and are shown in a probabilistic sense of what the storm surge result could be. And so, in addition to varying the landfall location, we also vary the size of the storm. We know that the size is really impactful for how much water could potentially be pushed inland. And so we do have a small, a medium, and a large size storm in our ensemble, as well as a fast, medium, and slow storm. And then we also vary that intensity. We have a stronger and a weaker member as well. So in the end, that ensemble that we create is hundreds of tracks, hundreds of potential storms that could hit the coastline. And so we run that through the probabilistic storm surge model, and we are able to get results within an hour of those hundreds of realizations and composite them to create our probabilistic answer. So this is kind of the summary slides telling you when P-surge is available. This is our real-time product. Remember, we run it definitely when there's a hurricane or a storm surge watch or warning, but it could be provided up to 72 hours prior to the arrival of tropical storm force winds, when we have some good confidence about the forecast situation. So you could potentially see P-surge results without any storm surge watch in effect. And remember, it is going to take a little bit of time to run those hundreds of realizations, and it is based on the official forecast that comes from the hurricane specialists. So at the advisory time, when they issue the official forecast, we start running the P-Surge model. It's going to take about 1 hour for the P-Surge model to run, and so you won't see that data until an hour after the advisory time. And then the output of the P-Surge model is going to be used to generate one of our main products, which is the potential storm surge flooding map. And it's also used to create other local NWS products as well. And so you won't see those right at the advisory time either. Those will take time because it does come straight from this objective guidance of P-Surge. So let's get back to this Hurricane Sally example. So this was our 24-hour forecast. The skinny black line was making landfall west of Mobile Bay, when in reality, it ended up being more of a Pensacola threat. So our forecast here really wasn't showing, it was showing limited threat to that Pensacola area. And this is not the way that we forecast storm surge. We do not use this skinny black line deterministic approach, but rather we use the P-Surge approach, that probabilistic, that ensemble or family of storms. So to take a look at what this looks like in terms of P-Surge output, you can see the swath of potential storm tracks instead of just that skinny black line. And the threat in Pensacola is much more significant given this ensemble approach, and it allows everyone along the coastline to plan appropriately. So again, that probabilistic shows a much larger threat in that Pensacola area. All right, so this is our first poll question here. And it's going to be about vertical datums. Maybe the question should be, what is a vertical datum? But here's our knowledge check. In general, NHC operational storm surge products provide water levels above which reference level? Is it mean sea level, MSL, ground level, AGL, NAV D88, or normal tide levels? All right, so we'll try and pull up the results here. Awesome. So it looks like we have almost 300 votes coming in. We'll keep going a little bit longer, but there does seem to be a split. Okay, yeah. Thanks for voting, everybody. And so I don't know if you can see the results, but the top vote winner was above ground level. So 35% of you thought that it was above ground level, and that's right. So I kind of mentioned it previously, but from now on, I'm going to be discussing strictly above ground level. That is the way that we're going to communicate and provide storm surge forecasts to the public in that manner. And so, you know, we do have tide in our model. We have all these things. So there's no need to do any sort of additional conversion. We're providing that above ground level forecast, and that is what you can pass on to your end users. So maybe another question for you is, what is a vertical datum? And so as we talk about above ground level, I can define vertical datum for you as well. So a vertical datum is just a reference level from which we start measuring. And so you can see a few different acronyms here on this slide. Let me describe what the colors are first. So here you have your kind of lighter blue color is your normal water level. And if a storm were to come in and you had storm surge, your water level raises kind of to this darker blue. So this gray is your sky. So how are we going to describe this storm surge water level? Like, where do you start counting from? Well, that's where your vertical datum comes into account. And so in this case, there's a couple different vertical datums listed here. If I were counting from NGVD 29 or the National Geodetic Vertical Datum of 1929, I could describe this water level as 4 feet above NGVD 29. But we know there's like many other ways to describe that same water level. You could describe it relative to mean sea level. Well, it's 3.5 feet above mean sea level. And so that is the exact same water level. We haven't changed anything about it, but it is described in a different way because we are using a different reference level or a different vertical datum. Another one that you may have heard of is NAVD 88, the North American Vertical Datum of 1988. The same water level could be described differently, being 3 feet above NAVD 88. So conversely, here on the beach, if you were to take a look at this point right at the edge of the dune grass, that is usually dry. And so if I were to describe the same water level relative to that point, I'd call it 1 foot above ground level, or AGL, like the last question described. So this water level, if you see a forecast from the National Hurricane Center, it would be described as 1 foot above ground level at that point. But you'll notice that there is a point here on the beach that's dry, and so that inland extent is going to be shown in some of our graphics as well that you can take a look at. But we are going to be giving in our forecast and distributing information as above ground level. So that leads me to kind of that potential storm surge flooding map, which is going to give you a look at the above ground level flooding and an inland extent and area map. And so you can call it the potential storm surge flooding map or the inundation map. Inundation is the same thing as flooding. So that is the amount of water on normally dry ground. So the potential storm surge flooding map is going to show the height above ground that water could reach. We like to call it a reasonable worst case scenario for any individual location. And really it's the storm surge heights at an individual location that have a 10% chance of being exceeded. So there's only a 1 in 10 chance that the storm surge height that you see on this map could be topped. That makes it a really great height to plan for. So 9 out of 10 of those scenarios at that location had a storm surge value less than that amount. And so, you know, you'll find yourself prepared when you plan for this height. And remember, this is not going to be a flooding footprint. We include a lot of different, a family of storms. We've changed the landfall location. We added different storm sizes. So it's not the effect from a single storm, rather it's a great planning tool from that ensemble. And this is going to be issued and available at the exact same time as we run the P-Surge model, because remember, this is just coming straight out of the objective guidance of P-Surge. So this is going to be, model output. Specifically, does not include any, forecaster guidance from us specifically. It is a purely objective guidance. And so you can see some images here showing the flooding above ground levels. There is a color table that can be a little bit difficult to see. We described it a little bit in some previous slides, but the blues show up to 3 feet above ground. Yellow is greater than 3 feet above ground. Orange is greater than 6 feet above ground. And red is greater than 9 feet above ground. And so you'll notice that this bottom image has an additional, a couple additional colors in the legend. The first is this intertidal zone or estuary wetland. And so these are areas that routinely get wet during high tide. And so if you want to just focus on the areas where you're likely to have, communities and people and buildings, you can turn on this intertidal zone or estuary wetland layer to kind of focus in on those areas that you expect to be more high impact. And so that is an option on the website. It's web-based, so you can click it on and off, and that's available for you. And you'll also notice that the levees have a marker in this legend. You'll know your specific coastline if this applies to you, but we do not provide the map inside levee locations. But we can provide, some additional guidance if that is something of interest for your area. And we work closely with the Army Corps on those types of events. So just a little bit more about that intertidal layer. The estuary wetlands are along the top. This is like the mangroves, the salt marshes. Those are the types of things that we cover up with that gray area. We also added the non-tidal wetlands, some additional areas like the Everglades and the cypress swamps. And so those are the areas that will, are routinely wet and get covered up as that gray mask. So this is what the current wetland mask looks like in North Carolina. And it really allows you to focus in on the areas where you expect more high impacts and more, assets and people and buildings. And just another example, this was from Hurricane Florence, where we had a very high impact storm up the Neuse River in North Carolina. So, well inland, you might not think of this area as being a beach town, but they are very susceptible to storm surge along the river. And so without the wetland mask, you can see that, the water levels do look higher, but this mask allows you to focus in on the downtown area of New Bern and see the threat to that specific community, not in the wetland locations. So that is an example of with and without the mask. And again, online, you can use these tools both ways, so you can toggle back and forth. So with messaging, we talked a little bit about the color scale already and what it looks like. This is how the interactive graphic looks online on hurricanes.gov. So again, that red is greater than 9 feet above ground. You're able to zoom in and zoom out, and we recommend using this kind of at the community level. And really, this is the tool for the emergency managers for you guys to overlay on your assets and help make those decisions. I was talking about that inundation layer. So this is kind of where you can turn on and off that inundation layer. And there's a map opacity that you can look into. You have the ability to download the data and view it in your settings, although I know it's all in HurEvac, and that's a great way to do all your planning with this tool. And then just again, here's your messaging. Greater than 9 feet, is going to be above the roof of a single story home. And you can see the family inside, that these water levels really are life-threatening. And this goes hand in hand with the storm surge watch warning, which you discussed yesterday, where if we believe that there is a danger of life-threatening storm surge, you will see the warning. And this just kind of goes along with it to help map out exactly what parts of your community are vulnerable. So again, I'm going to walk one more time through this kind of timeline of products we have. We started the presentation talking about the risk maps. And so those are your moms and meows. Can't get my mouse. But okay, so at the bottom, you have your moms and meows. Those are the green and the yellow. These are our risk maps. They're for planning and mitigation. They're all available in the HurEvac tool for you to start using right now. Understand your vulnerability. Again, the moms are used for evacuation zone planning. Great for just understanding your vulnerability. They're pre-computed and available right now. Once we get within 72 to 48 hours of landfall, you're going to start to see those probabilistic products that we were talking about. The P-Search model is run about 72 hours prior to the onset of hazardous conditions. So you're going to begin to see that information come in, and you'll see the potential storm surge flooding map, which comes right out of P-Surge. And then once we get within the watch warning time frame, you'll also see that peak storm surge forecast graphic and the storm surge watch warning together. So those timelines are kind of in that response phase. And so I think that is all the information I have for you. If you have any questions about the products, please put them in the chat. We've got a lot of information there for you guys. So I appreciate it.
All right. Well, thank you to the National Hurricane Center instructor team there for a fantastic Unit 3 presentation. Now's the time to take our first and only break of the day. So we'll break now, and we'll be back here at 2:35 Eastern, so about 15 minutes. Thank you so much to the NHC team. Fantastic presentations. If you have questions, please drop them in the chat. They will continue to respond and answer them, and they'll be around for support throughout the entirety of today's session. So if you have questions about decision-making products, as well as products that the NHC uses to incorporate uncertainty, those probabilistic products, please feel free to put them in the chat or in the Q&A box, and we'll make sure to get those answered. Let's see, I had a few pop up now if we want to just do some quick ones, if that's all right with you.
Sure.
All right, sounds good. All right, so we've had several questions back and forth between about above ground level and datums, specifically NAVD88. Can you just run through how that's calculated and the importance or the understanding that emergency managers and end users should take away from above ground level as essentially as a calculation of the slosh products?
Sure. So yeah, I know it's like datums can be one of those sticky points. So the slosh model that we did talk a little bit about, your coastal surge model, it is run in NAVD88. So the underlying data that comes out of the model is NAVD88, but we do all these calculations to provide it. The digital elevation models are available in NAVD88, and we do the subtraction and provide the potential storm surge flooding map in above ground level, because it gives you that point of reference of where I'm standing, what is the water height going to be at my location. And so that is a great way to communicate with the public, so they know exactly how high is it going to be above up my leg or over my head. And so I think that is the best way to communicate with the public, and that's why we provide it in that way. But if there are other specific locations where you have a vertical datum reference height and a decision point to make, we're happy to work with you on other vertical datums and conversions, because vertical datums are not easily converted between each other. It's definitely something you don't want to go alone. So either reach out to the HLT or your local National Weather Service office about any conversions or specific decision points you have at specific datums.
Thank you so much. And one final question before we transition to break, and I'll give you 15 minutes after this question's answered, just so I'm not cutting anyone short here. Very good question in the chat about the 10% exceedance. And so the question is, so within slosh products that are produced, individual locations have a 10% chance of being exceeded. What does that mean in terms of consequences and risks, and how should emergency managers be understanding and thinking about that when it comes to the risk perception?
Yeah, so the 10% exceedance can be a little bit difficult to wrap your head around, but it's all based on that ensemble of solutions. And if you don't want to think, you want to think about it just slightly differently, you can flip your mindset and think about it as the 90th percentile. And so 9 out of 10 simulations have a water level less than what you are showing there. And so just like 1 out of 10 exceed it. So you can think about it, in that way, flipping it to kind of help you wrap your head around it. But we do find that the 10% exceedance is the best planning tool. And so we run verification statistics on the probabilistic storm surge model. And we have published some of that in some peer-reviewed journals. But we find that, especially at the longer lead times, the 10% is the way to go for planning. And we find that it is definitely for those high impact scenarios like Hurricane Florence, we found that in New Bern, the 10% exceedance did extremely well at 72 hours and highlighting the risk to the Neuse River and to New Bern. It did really great during Hurricane Ian to highlight the risk in Fort Myers Beach. So we're finding countless examples, and the verification statistics show that the 10% exceedance is the best planning tool to use. And we are evaluating the utility of the other exceedance levels. And that, is something that the science is still being worked on and potentially could, change in the future. But the verification shows that the 10% is the best planning tool.
Yeah, fantastic. Thank you, Laura. So we're going to transition to break here, but just a final piece of so what I took away from that. When it comes to incorporating storm surge risk into your plans, that 10% exceedance, really make sure that you're encapsulating and incorporating all the worst or most of the worst case scenarios, or what you could actually see based off storm scenarios. So it's a good planning product. It is probably a bit more risk averse, but like you said, it is constantly being verified against operational surge products as well as observed surge heights. So thank you, Laura. Thank you, NHC. Let's take our 15-minute break now. So we will be back at 2:40. Please keep the questions coming in the Q&A box. We will be able to answer them as they come in, but give us a second because you all are a very curious bunch. So thank you all, and I'll see you at 2:40 Eastern. Thanks all. All right, well, good afternoon, everybody. Good to see you all again. You all know me well. My name is Zane Heather. I'm the National Hurricane Program Manager, FEMA's National Hurricane Program. As you heard a bit earlier, I guess at the beginning of the session yesterday, the National Hurricane Program is an interagency partnership between FEMA, U.S. Army Corps of Engineers, and the NOAA National Hurricane Center. And it is the program and the interagency partnership that is bringing you this training. We're going to get into Unit 4 here. This is the last unit of the course, and I know it is sad to be wrapping up here, but I just want to thank you all for the time you've taken out of your day, 2 days here, to sit down and be with us over this training course, as well as all the great work that you do for your constituents, your jurisdictions, and the nation at large. As you all know, hurricane season is quickly coming upon us, and this type of preparedness work and training efforts are so critically important to making sure we as a nation and as an emergency management enterprise are prepared. And we're with you every step of the way. So at Unit 4, we've got making better decisions or making more informed decisions. And before we get into it, just some last notes for housekeeping. Upon the conclusion of this unit, we'll have general question and answers. Again, we'll continue to address your questions in the Q&A box as they come up. Additionally, if we've got time left, so if we can wrap up before around 4 p.m., I will give a quick demo or overview of the HRVAC workspace. If you've not heard of HRVAC before, don't you worry, you'll hear a lot about it in Unit 4. And I just want to make sure that you are associated with the tool, where to get more information and resources, as well as how to access and register for an account. So if you'd like to stick around for that, please feel free to do so. And then finally, upon the conclusion of this webinar, as you all know, if you would like NDEMU approved credit for K0311, you'd have to go through the registration and the NDEMU course survey process. But there will also be a short survey sent out to you participants and registrants via Zoom, via webpage post-webinar. So just want to let you know that upon ending this webinar, you'll be directed to a webpage giving you 10 to 11 questions to fill out. If you can take 5 minutes out of your day to fill that out, that'd be very much appreciated. That really helps us to continue to right-size these efforts and support you all through these virtual training deliveries. So again, in culmination, we'll wrap up. I'll do a quick tour and overview of the HRVAC workspace as we've got time. And then upon conclusion of the webinar series of this training, you will get a short survey sent your way. Please feel free to fill it out if you've got the time. And again, thank you not only just for your time and attendance today and yesterday, but also everything you're doing for the nation and for your jurisdictions. Okay, what are we going to cover in Unit 4, making better decisions? So at the end of this unit, you'll be able to identify the components of hurricane evacuation studies and the relevant data therein, namely hurricane evacuation clearance times for planning and operational purposes. You'll additionally be able to identify the capabilities of HRVAC and the Hurricane Evacuation Decision Support Tool. Like I said, there will be hopefully a quick demo, time for a quick demo on the conclusion of this series. And then finally, you'll know how to apply NHP products and services and general decision support tools for planning and operational purposes to make informed decisions at the end of this course. So what have we learned thus far, and how does it all come together and tie up in K0311? Over the last 2 days, you've heard about hurricane climatology and meteorology. You know now about the hazards or been refreshed on the different hazards: storm surge, inland rain, riptides, wind, tornadoes. You know what types of products exist out there produced by the National Weather Service through the national centers, the Hurricane Center and Weather Prediction Center, as well as Weather Forecast Office, as well as how uncertainty is baked into those products and where there are probabilistic approaches being used and how you can use those to make more informed decisions when there's uncertainty in the forecast or in the products themselves. And then finally here in Unit 4, we'll talk about how that all comes together and what sorts of tools, services, as well as data is out there for you all as emergency managers and the EM community to make informed decisions in the planning and operational efforts that you have around hurricanes and hurricane evacuations. You all know this. This is probably just very high level overview information for you, but it's not all about the plan. It's also about the process. And the planning process is a result of the plan building itself. And so you all know the 6-step planning process, I'm sure, from Comprehensive Preparedness Guidance or CPG 101. 6 steps laying out how you develop the plan, how you get the team together, how you understand the situation, steps 1 and 2. Steps 3, understanding the goals and objectives of said plan, and then the development, preparation, review, and implementation of said plan. You also know that this is not a process that you do one time, but a reoccurring process and something that you do over and over again, probably yearly or quarterly as maintenance requires. You also know that a big part of the process itself, is a result and is an objective of the planning process. So it's not all about the plan, it's also about the process. And so what types of things can you all use and the emergency management community at large use to inform this planning process, as well as get to step 1, understanding the situation? Today, we'll talk predominantly about hurricane evacuation studies, but there's a wealth of information and different tools out there, both within the National Hurricane Program and within the emergency management enterprise at large that you all can leverage. But it's not only about the information you're using, but also ensuring that you've got the right tools, the right time, and the right reason to apply that information to inform your decision making. So the tools we'll discuss, the timing to some extent, and then the reason has been discussed over the past 3 units as well. So the tools we'll cover in Unit 4, the timing and the reason will all be informed by forecast products and where you find yourself in the preparedness cycle as you prepare for hurricane season. So again, it's not just the plan, it's just the process. And the process that we look at is the study, plan, and execute process. It is displayed here as being a stepped process, but really this is cyclical. You have to study and understand the situation. You develop the plan, execute said plan, and that, and in turn, influences what the study looks like to improve upon that plan going forward. We'll walk through each of these steps individually. The first piece of the process is study. That's where you identify your hazards and the threats to your specific location. You also understand the vulnerability that your location or your jurisdiction has to tropical cyclone hazards. That could be the vulnerability of populations at risk and exposed. It could also be critical infrastructure. We'll talk about that here shortly. And then finally, you also need to develop those key planning assumptions related to evacuations and hurricane evacuations, namely things like hurricane evacuation zones, hurricane evacuation timing. Before we get into that, one quote that I really enjoy and then really ties back to this effort at large, and it's by Nate Silver from The Signal and the Noise. We're not much smarter than we used to be, even though we have much more information. That means the real skill now is learning how to pick out the useful information, and I would say how to apply it at the right time. And so we've talked about all this information that's out there for you: forecast products, climatology of hurricanes, and now we'll talk about how to identify what you need to use, when you can use it, and when you should use it, and the types of tools and resources available to you all as emergency managers to apply it as well. Just a quick shout out to Matthew Green, who is a hurricane liaison team manager, who you heard from in Unit 2. He is also featured in this book, and highly recommend anyone online that wants a bit more information about how to make sense, given all the information and data that we have available to us at large day to day. So the big question, the first question within study and within the study part of the process is, how do you understand the threats and hazards that affect your jurisdiction, your community, whatever the planning, the planning area that you have under your purview is? There's a lot of different resources out there. We're going to deep dive into a few of them, but just for y'all's awareness, and this shouldn't be really anything new for most of it, is typically coastal jurisdictions impacted by hurricanes or threatened by hurricanes have active hurricane evacuation studies, or HESs, as I will refer to them as from here on out to save my breath. THIRA processes ongoing, so the threat and hazard identification risk assessment. You also have other things like flood risk maps, FERMs, hazardous modeling, depending on where the threat is, as well as historical incidents and local knowledge. One thing that I will say is historical incidents and local knowledge are premium when it comes to injecting that sort of information into your planning processes. You know this. You also know your jurisdictions better than any hurricane evacuation study or any of these static or dynamic geospatial products can inform. It does. Excuse me. So just make sure that all this information is caveated and interplayed with your historical knowledge and your subject matter expertise of your planning jurisdiction. So next, we're going to dive into the Hurricane Evacuation Study, or HES. Hurricane evacuation studies, if you've not heard of them, are federally supported, state managed, and locally executed. Typically, the regional hurricane program managers of the National Hurricane Program and the USACE, or Army Corps of Engineers, district study leaders work hand in hand with state program managers to manage the day-to-day operations of hurricane evacuation studies, and they're informed from the local level. Hurricane evacuation studies are comprised of 5 component analyses that are comprehensive in their nature and build off each other. The first one is the hazard analysis, essentially what will be wet, what stays dry, what sorts of threats and hurricane hazards impact a specific jurisdiction. The next one is the vulnerability analysis. Of these areas that are exposed or threatened by hurricane hazards, what are the vulnerable populations or exposed populations, as well as exposed infrastructure, both critical infrastructure and transportation infrastructure. Next is the behavioral analysis of these exposed populations. How do we expect they will behave? The people that are in harm's way that will receive hurricane evacuation orders, how will they react? Next is the shelter analysis of that exposed population. How many of them do we expect will need public sheltering? And then finally, transportation analysis, using all the information and data that is gathered in the first 4 analyses. It aims to tell you, of the population exposed to hurricane hazards, how do we expect they'll react, and how long will it take for them to evacuate? The 2 biggest things produced through the HES, although there's a wealth of information and data, are hurricane evacuation clearance times, how long it takes for an impacted population and evacuating population to reach an assumed point of safety, as well as hurricane evacuation zones. And we'll get into all of that here briefly. One of the big things with hurricane evacuation studies is that it is essentially the foundation for hurricane evacuation plans, but it is not the plan. Again, this is the study part of the process. This is getting all that wealth of information, all of that data in one succinct place that then can be used to inform hurricane evacuation plans, hurricane evacuation decision-making. And we'll talk about operationalizing hurricane evacuation study data here in a bit. All right, so the first frequently asked question, or first question that we have during the hurricane evacuation study process is, what will be wet, what will be dry, how high will the water get, how far inland? And essentially, the hazard analysis, that first analysis within the HES process, will give you that information. I want to take a step back here, but it's important to understand that the hazard analysis of the HES is a comprehensive look at all of the tropical cyclone hazards or hurricane hazards that might impact an area. So while we are predominantly focused on what is wet and what is dry, inundation, because as you all know, as you've learned over the past 2 days, inundation is the largest driver of loss of life, and storm surge or coastal inundation has the largest potential for loss of life. So when we think of evacuations, population protection, moving people out of harm's way, really we try to focus on inundation and storm surge inundation. But that's not to say the only thing that's involved in hazard analysis for hurricane evacuation studies is that inundation piece. We also look at inland wind decay. We also look at, obviously, wind risk and threat and other things as identified by the jurisdictions, such as landslides, coupled flooding. So that would be coastal coupling, which is freshwater and saltwater inundation, and then other things as other hazards as identified by the state or local jurisdictions. So to take a step back, like I said, inundation is what we're primarily focusing on. And of that, it is storm surge inundation that primarily drives evacuations and is the basis for hurricane evacuation zones, which help us communicate protective action decisions, i.e. evacuation orders. How those are typically developed, and it depends state to state, locality to locality, where their interest and expertise lies, or what the threat looks like, or the hazard profile looks like in that area, is through using the SLOSH, MOMS, or MEOWs. So those are the storm surge planning products that we learned about previously. Using the MOMS and MEOWs, we have a good understanding, or 90%, or an understanding up to the 90% exceedance level of what the storm surge risk is in inundation depth for this specific place. So as you all have just heard, it's not necessarily saying that this is the footprint or the expected inundation extent, but rather at this specific location for a MOM, which would be a category of storm, we expect this specific inundation level or height, and that's above ground level in feet. We look at this map that you see in front of us. This is an overlay of slosh moms over St. Tammany Parish in Louisiana. If you start closest to the coast in that bright red color, that is the tropical storm level, the tropical storm mom, and only the tropical storm mom. So that's, excuse me, that is the extent of tropical storm. But as you go all the way back, 5 different layers, multiple different colors, up to that purple color in the back, that purple color is depicting the category 5 maximum, category 5 mom. Everything from there on down is a different category storm. And essentially it is telling you, based off that category, this is the inundation level risk driven by the mom. So if we go forward, the next question is, how do we take this storm surge risk information and use it to make something that is actionable as well as easy to communicate to the public? And essentially the way to do that is through the creation of hurricane evacuation zones. Hurricane evacuation zones can be built using moms or meows, and essentially what they are risk-informed zones, so using that storm surge risk that are tied to local, human, and physical geographies. So that's to say they're informed at the local and state level. They're tied to things that are pertinent for that specific community in a way that is easy to communicate. And so that can be that can be using geographic landmarks, community landmarks, as well as things that are tied to local expertise and knowledge of the impacted or area at risk. So as you can see here, on the left, you've got the mom, the slosh mom. That is, there's a lot of, it's a mosaic of different colors. It'd be really, really challenging to communicate that to any member of the general public, especially if you look in that area in the bottom right where you've got that inlet and it looks like a different discharge zone with a lot of streams, bays, and bayous. How do you communicate that specifically to someone that would need to seek protective action or take protective action in those storm surge areas? And the best answer to that is through the creation of a hurricane evacuation zone, which you see on the right between zones 1 and 3. And essentially what that is using or what that is doing is pulling together that storm surge risk as it's tied to local geographies, namely that interstate that's running left to right through the middle of that jurisdiction to help communicate protective actions to the impacted population. So again, this is driven by risk. Predominantly storm surge risk is locally informed and then tied to geographic areas and geographic landmarks that are easy to communicate. There's several ways that you can create hurricane evacuation zones. The one we just looked at there was using the maximum or MOMS, but you can also use a different approach, which is using the meows. The reason that you'd use the meows over the MOMS is it gives you a bit more of a refined approach to how you're selecting and identifying which evacuation zones you would be calling in an operational scenario. What we're looking at here is New York City, a very obviously population dense area with a lot of gridded streets that you can use for geographic reference. And because of that, that gives them the ability to be much more precise with the delineation of their evacuation zones. So on the left, you've got the storm surge risk product. That would be a meow. From there, you've got that overlaid on the physical geography of the location. And you can tell those storm surge delineations follow streets, which would be easy to communicate. And finally, you've got evacuation zones on the right, the final product that would be communicated to the public for planning, preparedness, and operational response. Then that's informed, or the calling of those zones is informed by a composite or directional meow approach. So previously we talked about using the MOM, which is essentially tied to the category of storm. As you all now know from that last presentation, meows don't only look at storm category, but also additional storm characteristics. Those characteristics are angle of approach and forward speed. And so New York City can make a informed planning and operational decision based off a storm forecast to what evacuation zone they should be calling, not only on the category of storm, but also how it is approaching the coast and the forward speed at which it's traveling. So you can see there in this table on the bottom left that not all storm scenarios are created equal. There are times when a category 2 storm with a different angle of approach will drive more surge inundation, substantially more surge inundation than a category 4 storm. You can see that category 2 at a west-northwest angle of approach is 20.9 feet, while category 4 storm traveling to the northeast or away from New York has 14.6 feet. And so what that enables New York to do, or New York City to do, is look at a storm forecast and make an informed evacuation decision, not solely off the category of storm, but also the angle of approach. This is a job aid that New York City created to help inform that evacuation, the evacuation zone delineation and evacuation zone scenarios. One thing that is startling, and again, this is relatively old information, the 2010 census, but depending on the information or the calls that they're making tied to a storm scenario, they're looking at somewhere around 3 million people evacuating. So for population dense areas, it's extremely important that you are as precise as possible when it comes to evacuation zone delineation and also setting up the information and the decision making processes so that you can make an informed decision based off of things that aren't just that are not solely based off of storm category. All right, so the next question we'd like to ask in the hurricane evacuation study process is who will be affected and what critical facilities are at risk. And where we go to get that information is the vulnerability analysis. The vulnerability analysis looks at the exposed populations, the exposed areas within the hazard analysis, and tries to quantify the exposed populations within those areas, as well as the critical facilities and general infrastructure at risk. That information is typically produced via tabular data and geospatial data. So for example, this is an example from Hancock County, Mississippi, looking at residential structures that would be impacted by different scenarios, different storm categories, based off of the storm surge information and hazard information pulled from the hazard analysis. So again, hazard analysis looks at the threats that hurricane hazards pose to a specific area, where the vulnerability analysis looks at the exposed populations as well as the exposed infrastructure within those threat areas. So this is another good depiction of a piece of data that is produced through the vulnerability analysis. This one is looking specifically at critical facilities. You've got the facility type on the left and the different number of the facilities that would be impacted based off of the different storm scenario. As I said earlier, this is not only represented via tabular data, but also can be and is represented geospatially, overlaying the hazard risk areas or hazard layers with geospatial data tied to both populations impacted as well as critical infrastructure impacted. One thing that's important to discuss right now, or to say right here, is that critical infrastructure, while we typically use a general understanding within the National Hurricane Program during the hurricane evacuation study process, it is fine-tuned and tailored to what the state and local jurisdictions deem as their critical infrastructure, and also looks at incorporating not just the geospatial resources, but also supporting the integration of this information and data into other planning products. All right, so we know what particular or what specific hurricane hazards or tropical cyclone hazards impact an area or can threaten an area. The next question we asked was within those risk areas or within that hazard profile, what types of populations and critical infrastructure was exposed? And the third question we ask is who will evacuate, where will the people go, and how do they understand the threat? And the way we get to this is through the behavioral analysis. And essentially, this helps the National Hurricane Program and the hurricane evacuation study areas understand how they and anticipate and draft behavioral assumptions around how the specific exposed population will react under a hurricane evacuation order and in the face of a hurricane threat. To do this, we conduct several surveys, or we've used several mechanisms in the past to support the behavior analysis. One of the predominant historical ways we've done this is through public-facing surveys. And after looking at and comparing those survey results over multiple jurisdiction areas, we've identified several key takeaways and important information for you all as planning practitioners. First, there's a serious underconcern about storm surge and storm surge risk. This could be for many different reasons, but as you all learned earlier, this training and know as emergency managers in hurricane-prone areas, the Saffir-Simpson scale does not say anything about storm surge risk. It is a wind scale, and it is the impacts typically associated with tropical cyclones or hurricanes because of that, as we've seen, are wind damages. So we've seen via our surveys that there is a serious underconcern for storm surge risk. Most often, the evacuation intent of an exposed population is overstated. It's always different responding to a survey during a blue sky day when it's beautiful about on the worst of days, what would you do? We found that people typically say they're more often going to evacuate than we see operationally. And then we find that evacuation intent is highest for major hurricanes, category 3 and above, mandatory or ordered evacuations, households with children, and then people with recent real hurricane experience. And I would like to put emphasis on the real side. And so this means that they've lived through a hurricane landfall or seen the impacts and effects of a hurricane firsthand. As you all know, you will have to make challenging decisions when there's uncertainty in the forecast, and this will often cause, or this often means that areas will evacuate that do not get the final, that are not the final landfall location of the storm, and do not see the hazards that they anticipated when they made that decision. And so that at times creates a false experience effect, which can lead to people not evacuating when they said that previously they would. So again, the emphasis is on the real hurricane experience. And we have seen, or through the surveys that we have seen, that there is a false experience effect that happens when an evacuation is ordered, but those impacts, the anticipated impacts, are not realized. All right, so the next question and the next thing to keep in mind is, will the people evacuate? And what can influence a person to evacuate? And so through these surveys, we've seen that the likelihood of evacuating changes based on how the evacuation order is worded and delivered. And so, as you can see, the likelihood of evacuating, if there is an evacuation recommendation or a voluntary evacuation order, 50% of the survey respondents said likely, 18% said neutral, 30% said unlikely. Once that changed to an ordered or mandatory evacuation, we saw via survey results a much different result. So if there is an ordered or mandatory evacuation, we saw, or based off survey responses, we had 75% of the participants said they would likely evacuate, 9% said they were unsure or neutral if they would evacuate, and 15% said it was unlikely that they would evacuate. So one important takeaway for you all as emergency managers, people that will be hopefully not anytime soon, but could be drafting evacuation orders or supporting your elected officials in delivering evacuation orders. We've seen in our surveys that the way those orders are pushed out and the language used is extremely important. And so that ordered or mandatory evacuation typically drives more population participation than a recommendation, or, as you see here, a voluntary recommended order. The last part, that the last key piece of information that you can pull from behavioral analysis is essentially where you can target outreach efforts. And so using the survey mechanism historically, we've been able to identify different areas or subsets of the population, both geographically distributed, that perhaps have a different understanding of their hurricane risk or tropical cyclone hazard risk than they should, or also have understated their intent to evacuate. And so using this information, you as emergency managers can help target public awareness and outreach campaigns to make sure that there's a good understanding in your jurisdictions of the risk posed by tropical cyclones and what to do if one were threatening. All right, so the bottom line, the key takeaway from the behavioral analysis and what we've seen through our survey data is people typically evacuate because they understand their vulnerability and the risk, and they were told via mandatory evacuation orders to evacuate. All right, so we've talked about hazard analysis, understanding the hazard risk profile of a specific location. We've talked about the behavioral analysis, the vulnerability analysis, how the population within that risk profile will, we talked about the hazard analysis, which is the risk profile of a specific location. We've talked about the vulnerability analysis, which is essentially what populations and infrastructure reside within that hazard risk profile. We've talked about the behavioral analysis, how will those exposed populations react to a hurricane threat, as well as an evacuation order. And then now the next question is, what percentage of that evacuating population will seek public shelter? How many shelter spaces are needed? And how many people will shelter within the jurisdiction or county? And how many will be evacuating out of the county? And the analysis that we use to respond to those questions or provide data on those questions is the shelter analysis. Within the shelter analysis, we develop a repository of shelter locations with respects to hurricane evacuation zones and storm surge flood risk areas. Additionally, we develop and analyze potential demand based off the previous analyses and storm scenarios for public shelters. And using that shelter repository that gives us the shelter numbers as well as shelter capacity and the anticipated demand based off storm scenario, we use that to identify shelter deficits. So based off of what's available and what we can expect, how many beds do we have and how many beds do we need, and where is there a delta between those two numbers? Typically, what we've seen historically in hurricane evacuation studies, again, via the behavioral analysis and the shelter analysis, is that the planning assumptions used for shelter rates are between 3 and 8% for coastal jurisdictions and 10% for inland jurisdictions. This is a good example of a shelter supply and demand analysis. This was done for Baldwin County, Alabama, in their hurricane evacuation study. And as you can see, it gives different scenarios for sheltering based off storm category, which is the columns. And then up at the top on that top row, different planning assumptions for shelter need. And so you've got low occupancy, high occupancy for both sheltering demand and supply. And you can see where those two things meet up in the final two columns. So again, based off the storm scenario, category 1 through 5 on the left, and then crosswalk between different evacuation scenarios, both with low evacuation population occupancy and low shelter demand or high shelter demand occupancy, crosswalking that with shelter capacity, we're able to identify where we have shelter surpluses and where we have shelter deficits when it comes to evacuating in storm scenarios. As you can see in the bottom right, there's several deficits that have been identified, namely during storm scenarios for major hurricanes, or at least category 4 and 5, when there is increased demand for shelter capacity. Another way that jurisdictions have used this information or operationalized this information, and another product that is produced through the shelter analysis, is essentially based off the shelter demand percentage and the total evacuees. What is the demand and what is the supply, and then where is their overcapacity? So if you look on the left, you've got the percentage of evacuees seeking shelter. After that, you've got potential evacuees, so the total number of people evacuating. And then after that, on the third column, you have the regular capacity of the shelters, emergency capacity, and then identifying where those two numbers are not meeting up. All right, so we've got an understanding of the hazards posed to a specific location via the hazard analysis. In the vulnerability analysis, we understand the populations and infrastructure exposed to those hazards. In the behavioral analysis, we know how that exposed population will now react. Shelter analysis, we know what percentage of that population will be seeking public shelter. And then finally, the final analysis done in the hurricane evacuation study is the transportation analysis. And that helps us understand how that evacuation will move through the roadway network, as well as how long will it take for that evacuating population to reach an assumed point of safety. So the big question we're trying to answer, and the big thing we're trying to produce through the transportation analysis, are evacuation clearance times. Essentially, how long will that evacuation take from the time that first car enters the roadway network until that last car reaches a quote unquote assumed point of safety. So how do we develop those clearance times? The National Hurricane Program uses the real-time the evacuation planning model, or Route PM. It's a proprietary model owned by the National Hurricane Program to develop those clearance times. And essentially what we do is we input data and information comprised and pulled from the previous 4 analyses into that model, and we overlay that on the evacuation roadway networks and integrate additional planning assumptions. So we've got the vulnerability, we've got the exposed population and demographics, we've got the behavioral assumptions developed through the behavioral analysis, we've got evacuation routes, roadway capacities, destinations, and evacuation scenarios developed in hand with our state and local partners, and we run that through our evacuation planning model. What does it spit out on the back end? 2 very, very important pieces of information. One is traffic patterns, how that evacuating population moves through that roadway network, and then finally clearance times. Within the traffic patterns, it'll help us identify and helps state and local partners identify, based off the evacuation characteristics, where there are bottlenecks in the evacuation roadway network, as well as different strategies that can be employed to help reduce those bottlenecks and those clearance times. And then finally, you've got your evacuation clearance times. And that's based off several variables, as we've discussed previously, but some additional ones are the response rate, how quickly an evacuating population or a population told to evacuate will take action and will get on the evacuation roadway network. Next, it's seasonal populations, how many tourist or seasonal residents are currently inhabiting an evacuation area, apart from what is typically counted in their census. And then finally, additional evacuation scenarios based off of transportation, based off of evacuation and transportation planning characteristics, essentially. So based off the state and local plans, if they execute or utilize things like emergency shoulder use or contraflow mechanisms, we can put that into our model to help influence the clearance times. All right, so as I've said multiple times, clearance times are one of the main products of the hurricane evacuation study at large, but specifically for the transportation analysis. And again, this is the time it takes for an evacuation to be completed from start to end. And it starts when the first evacuated vehicle enters the roadway network, and it ends when the last vehicle reaches an assumed point of safety. It includes travel time and time waiting in congestion or queuing. Again, it does not relate to one specific vehicle. This is not how long it takes John Doe from Miami to get out of harm's way, but rather the total elapsed time of the evacuation. It is primarily driven by bottlenecks. Those bottlenecks are identified via our transportation model in the transportation analysis and can be used by state and local partners to build out different planning assumptions as well as operational plans to help alleviate the congestion caused by those bottlenecks. Here's an example of some of the end products produced by the transportation analysis. On the right, you have a clearance time table, and that is tied to different evacuation characteristics. One of them is response rate. The other one is occupancy. A lot of these, so when you take a step back, the evacuation scenarios are driven by key inputs and injects throughout the hurricane evacuation study process. And it's really up to the state and local partners to help us decide or help inform and influence how we are drafting this evacuation scenario, creating these evacuation scenarios, and which variables are the most important for them to be included in that process. And so on this table, you've got the different response rate and you've got different occupancy. Occupancy also can be read as seasonal population, but you have there's also additional variables that can be included in these tables in the analysis itself. Things like traffic control mechanisms, contraflow, emergency shoulder use, also things like the percentage of the evacuated population. So not just assuming 100% of the population will evacuate, but rather based off of the behavioral analysis, you can fine tune that to what you expect to evacuate within that risk area. On the left, you've got a map that helps identify the different scenarios as well as the different jurisdictions that are connected to the clearance times on the right. All right, so that was a 30,000-foot overview of the hurricane evacuation study process. Like I said, there's a ton of useful information and data within the hurricane evacuation study, but the main deliverables that are operationalized outside of the study, this is somewhat of a teaser in HERVAC, we'll get there in a second, are hurricane evacuation clearance times, as well as hurricane evacuation zones. One thing to note, all that information is available in HERVAC. Again, we'll get there in a second. And all of that information, or all the hurricane evacuation study information, is captured in the technical data report, or TDR, and is available to state and local jurisdictions and is able to be pulled out of HERVAC. And I'll point to where you can find that at the end of the session here. So like I said at the beginning of this unit, the HES really helps us understand the situation and is truly the study part of the process. It is not the plan, but is the foundations of the plan and gives the underlying data and planning assumptions that can be built upon for planning and operations. The next step of the process is using that information to inform your planning efforts. The way you do that is to inform both the hazard and risk perception that you have as practitioners, as well as for your impacted jurisdictions or relevant jurisdictions. And then the next time is to incorporate that information into planning tools that you have and operational decision support tools that you have and understanding what else is out there. And that could be via timelines or triggers. So in the planning process, after the HES and after all of the meetings that have comprised the HES process, we are past steps 1, 2, and moving on to steps 3 and beyond. So we understand the situation. We have our collaborative planning team, the HES team, and next, as we move from the study to the planning process, we look at goals and objectives and the development of hurricane evacuation plans and operational plans. All right, so to do that, the first questions we try to ask ourselves is, what forces us to react as emergency managers? What is acceptable risk within our jurisdiction? And what assumptions can I make? And one way to do that, or one way to inform those processes, is through the identification of hazard triggers. And so I'm just going to go through some examples that we've seen for the operationalization and planning optimization of hurricane evacuation study deliverables. This is a great, essentially just a decision-making matrix here based off of thresholds and triggers. And so the decision factor you can see on the left is if the storm's current or projected intensity and the public perception of the threat and their safety. And so if it's category 3 or greater, that means one of several things will happen. And so based off of the storm scenario, you've got a trigger that means for your planning assumptions, you can go out and execute, and that'll inform your operations there on out. One of the things I like to identify here is they've got several different planning assumptions and triggers baked into this one graphic. You can see here on the bottom left, there's several different variables that could influence their ability or their plans their executions of traffic control and traffic control modifications such as contraflow and lane reversal. Here's another great way that we've seen, so Chatham County in Georgia operationalize the hurricane evacuation study information for their planning efforts and operational efforts. You can see here it's a matrix based off of storm category with evacuation actions. As the storm category grows, the different evacuation or response actions also grow. And then one thing I also like to point out here is they don't only have the clearance times, which is general population evacuation, but they also have clearance times associated with nursing homes and special needs evacuations. So when you think of those intern populations, nursing homes, critical care facilities, hospitals, prisons, those will all have different evacuation characteristics, different clearance times, and should also be baked into your plans. So you can see here, storm category, storm situation on the left, and then what evacuation actions that would trigger based off of the threat. So you've seen this graph before, and this is just a good reiteration of when is key information available that you can use to make informed decisions off of using hurricane evacuation studies or the plans that they inform. And so you've got the HES, and that is your year-round foundational data that helps inform the planning efforts, both for planning and operations of your jurisdiction. You also have several other data sets and information layers tied to the HES process that should be identified during the HES process. Those are things like your storm surge risk products and risk maps, your MOMS and MEOWs, which you know well, as well as other hazard information, hazard risk products. Again, available year-round, should be continually updated and consulted. Next, during hurricane season, you've got your tropical weather outlook, the TWO. These are your scary jelly beans out there. This is what's going to answer the question. So what is happening in the tropics and how alert and ready should I be? After you've got a credible threat, or there is a storm or an invest that the National Hurricane Center is producing advisories off of, you've got your public advisories. That's all the great information that we've overviewed over the past 3 units now become available that you can use to inform your decision-making, both for the HES and associated plans. And then when you have a credible threat for your jurisdiction, you've got additional information that is available in both HRVAC, you've got additional information that you can access, and you can find that in HRVAC more there in a bit, as well as things like planning storm surge products associated with storm characteristics like MOMS instead of MEOWs, and additional information produced by the National Weather Service. Well, as the threat becomes more credible, as the threat becomes more credible, and as it approaches landfall, you've additional information informed by the forecast itself. You've got your operational products like your P-Surge, which you heard about recently, as well as storm surge watches and warnings that you could use to help drive decisions and drive actions. So this is all to say, the information that you are utilizing and the products that you are utilizing to make these informed decisions will change both throughout the year, then also throughout the threat itself. And so there is a myriad of different products, and this is that timing piece that is so critical when it comes to making informed decisions, because the timing of that threat and when it reaches your jurisdiction of interest will really drive what types of products you're leveraging and the type of information that you can glean for them. All right, so question 7. We've talked about the triggers, we've talked about operationalizing that information. Now, the next question we have is, how do we know when to deploy that information? What types of products and services can we use? What type of information is out there? And how should they be integrated into our planning efforts? And the way that we've seen this operationalized or implemented in the past is through the development of decision timelines. This is a decision timeline that was developed by Horry County. And as you can see, it is tied to the arrival of tropical storm force winds. That is typically the first hazard to reach a specific location from a tropical cyclone. It is not always the first hazard, so make sure you take that with a grain of salt, but it is the hazard that we have got the most timing information for, as you've learned about in previous units. That's your earliest onset and most likely arrival of tropical storm force winds. Based on that, they have worked backwards to integrate different planning and operational assumptions. So you've got your clearance time with lane reversal, you've got your preparation time, and you've got essentially the total elapsed time you need to make for an evacuation decision. As you can see, that's 62 hours prior to the onset of tropical storm force winds based off this scenario, which is a long time prior to the onset of the hazard, and there's going to be a lot of uncertainty still in that forecast. So something to keep in mind. Another thing that I'd like to point out as well is this is not just tied to evacuation information, but they also have baked in additional emergency management operation information, such as opening EOC. So the big takeaway is if you're building out decision timelines, it doesn't only have to be for evacuations, but all the actions that you would like to make. And you can operationalize and integrate that information through various planning tools and products. Primarily, HERVAC is the one I'm going to talk about here shortly, but it should be comprehensive of your planning and operational posture leading up to this. One thing I'll say about clearance times, like I've said and reiterated, it is only the total elapsed time of the evacuation itself. It gives you no information about when you should call that evacuation order or when that evacuation should start. We'll get to a functionality within HERVAC which will provide a recommendation, but one important caveat is that recommendation should be informed additionally with your subject matter expertise and local knowledge as to when that evacuation should start. And typically that's based off of when is best to communicate evacuation orders, as well as when is the best time to start evacuation, typically early in the morning. All right. Another way that we've seen this time-bound information operationalized is through hurricane readiness checklists. So essentially just going through the checklist, and the checklists are tied to specific actions that happen specific to hurricane readiness or operations. Right here you see prior to June 1. So this is your time to dust off the books, time to kick the tires checklist to get ready for hurricane season. And then you also have operational checklists. So storm impacts imminent 36 hours. What should you be doing? What do we need to go down? What is the prioritization of events and efforts? And so my recommendation would be, if you're using this approach or if you have these checklists, make sure that they are right-sized to the timeline that you're working under. And I think a good best practice is to make sure or to ensure that it also looks at your yearly preparedness or prior to hurricane season efforts. Next, you can look at other tools to help with time-based planning assumptions. So this is a screenshot from HERVAC. I'll talk about this here in a bit. But essentially, all of this information can be integrated into HERVAC, the Hurricane Evacuation Decision Support Tool, to help inform your decision-making. I'll talk about HERVAC ad nauseum, so you're probably gonna get tired of me saying that. But essentially, HERVAC is the only tool that is currently available that is open to the general public, specific to emergency managers. So if you're if you are an emergency manager for a public institution at the federal, state, local, tribal, or territorial levels, you have access to HERVAC, and it integrates real-time forecast products with hurricane evacuation study and timing information to help inform your decisions based off of current threats and risk, as well as the planning assumptions and timing assumptions that are laid out in your hurricane evacuation studies or that you have on hand in your jurisdiction. So what you're seeing here are timing arcs. Essentially, it crosswalks pre-identified, or it integrates pre-identified time actions or time-bound actions that you, the user, have identified with a current forecast, and for the forecast that informs this is forward speed and maximum radius of wind, to let you know based off of where the storm is, when you need to make a decision. So you can see based off this example and the jurisdiction in question, we have 96 hours before impacts, or roughly between 96 and 120 hours before impacts are anticipated to make those decisions. Okay, so we've talked about the study, we've talked about the plan, and the next piece is to execute said plan. And again, understanding the tools and the timing that is critical to making an informed decision. And what do you need to execute? You need to understand the risk or the threat. You need to monitor the threat, you need to assess the risk and understand how that risk pertains to your specific jurisdiction, and then take informed action. Okay, so the questions that we typically ask ourselves, or emergency managers typically ask themselves during this phase: what is the forecast? What is the threat to my community? And what are the hazards expected? And as you all know, the best place to get that information is via the NHC forecast. So you all know, and I'm not going to spend too much time over this because I will not do it the same justice that the Hurricane Center did, but through the NHC forecast and forecast products, different products and services will become available as threats become more imminent and as a tropical cyclone or hurricane approaches land. So on the left, you've got the pyramid of products available. You were walked through that in this last unit, but essentially, depending on where we are in the year and where the threat is and how credible the threat is, there'll be different planning products or operational forecast products available to you and the general public to make informed decisions off of, with those products getting more informative, probabilistic nature, or as that storm approaches landfall. All right, so the first question is storm characteristics, and the main product through the main overview product through the National Hurricane Center Advisory Package that you will see first is essentially the cone of uncertainty and the associated watch warnings. As you all know, because you've been sitting and paying diligent attention in this course for the past 2 days, that this does not tell you much about hazards. It does not tell you much about timing. Really, the only thing the cone tells you is generally where the center of the cone is expected to go. So as we've discussed and as we've tried to reiterate time and time again, this should not be the main product or the sole product that you use to base your decisions off of. It's a good piece of information to know. It's good overview information, but there's plenty of other products out there that you can use to inform your decision. One of them are the probabilistic wind timing and wind percentages. And so you've heard about this, and we discussed this in the previous unit, but essentially we've got wind speed probabilities for each of the different thresholds, tropical storm, strong tropical storm, and hurricane force winds, as well as wind timing information that you can gather from the National Hurricane Center forecast products. This tells you not only what the probabilities of feeling those wind forces are, but also the associated times at which those hazards could onset. So important to know, what are the chances and when's it going to arrive? 2 big questions we try to answer to inform the decision making. On the left, you've got graphical wind speed probabilities. You saw how this was developed, essentially a probabilistic approach to the wind that you could potentially feel in that specific location. It is important to in informing and influencing your decisions because it'll tell you what are the chances of feeling this hazard are. Next, you've got the peak surge forecast on the right, and that essentially gives you a range or forecast of what surge could be based off of the P-surge model that you also learned about in the last unit. So essentially, this is a great way to understand what the storm threat is and understand it in a probabilistic manner. So what are the percentages? What can we anticipate? Not necessarily what is the forecast or skinny black line telling me. All right, so you've got the forecast information. And so your question now is, how do I take all this information and how do I integrate it with my planning assumptions and the hurricane evacuation study or general evacuation information that I've developed to help inform operational decisions? And the answer to that is HRVAC. And you've heard me talk about and tease this for the past hour here, so we'll get into it now. My first question to you all, and if you're hearing this for the first time, welcome. How many of you all have a HRVAC account? Oh, thank you. So how many of you all do have a HRVAC account? Yes, A, and I use it regularly. B, yes, but I'm unfamiliar with how to use it. C, I just registered for an account and I want to say thank you to the 9, maybe 10 people that just did that. I'm doing my job. And D, I do not have an account and I expect to see 145 registrations after this closes up. So I'll give it a few more seconds. All right, so it seems like we've got a good mix here with about half of you not having had a HRVAC account before, heard of HRVAC before, and the other half of people on using HRVAC or at least somewhat familiar with the account. And so what is HRVAC? One second. So HRVAC is a hurricane tracking and decision support tool supported by the National Hurricane Program. It uses and ingests National Hurricane Center and National Weather Service forecast information and data. So this is specific to the forecast advisory packages produced by the National Hurricane Center, as well as general to a lot of additional products produced by the National Weather Service that look at other hazards associated with hurricanes, as well as other real-time meteorological conditions or weather conditions. And then it gives users the ability to integrate that information with hurricane evacuation study information to inform time-bound, risk-informed decisions. The hurricane evacuation study information that is most accessible in HRVAC are hurricane evacuation clearance times, as well as hurricane evacuation zones. This provides emergency managers a common forecast picture, a common operating picture on which they can base evacuation decisions. And it also develops and produces wind timing, evacuation timing, and storm summary reports that can be used to inform your decision-making, as well as give out situational awareness reports and briefs to your team and your leadership. So HRVAC is a web-based tool, so no downloads or software needed. It can be accessed on your computer or tablet and is free to government emergency managers at all levels. So if you're at the federal, state, local, tribal, or territorial level, you can go and register for a HRVAC account. If you got a .gov in your name, it'll be easy. If not, it's just going to ask you what your connection is. And if you're tangentially connected to the public service emergency management space, you might need to get a referral from a state or local emergency management agency, or just provide your use case and we will review and approve those as needed. But essentially, it is free and open to use for public sector emergency managers. It is the only place where you can get hurricane evacuation study information that is free and open to use, and also contains a lot of additional emergency management relevant information that can only be accessed in HRVAC. And we'll talk about that in a bit. Also in HRVAC, you can find all the SLOSH, or the storm surge risk information that we discussed throughout this course. So that's your MOMS and MEOWs, fantastic acronyms. You can also get storm surge hindcasts. So essentially using the SLOSH model to look at using the SLOSH model post landfall, running the best track of the storm through the SLOSH model to understand or give a initial assumption or initial breakdown of where storm surge flooding could have occurred. This is not baked in, or this does not incorporate a ton of real world or real-time observations. So it's almost purely a model run, but is a good first estimate for storm surge extent and depth that can help inform immediate response and search and recovery efforts. Lastly, to register for a HRVAC account, just go to www.hrvac.com or that link right there. We can drop it in the chat for you all. And like I said, if you have an emergency management use case or tied to a public sector emergency management organization, you should be greenlit and expedited through that process. All right, so what are some things that you can access in HRVAC? And right now, what you're looking at is the HRVAC, is a screen clipping of the HRVAC application itself. So I'll go through and do a quick demo after this, but essentially you've got a ton of different functionalities. And as you go in, it's essentially a geospatial platform to interact with current storms as well as archived and historic storms, integrate that forecast information with the planning and timing information developed by hurricane evacuation studies. So in HRVAC, on the left, you've got the storm tools bar, and you can use that to access things like the forecast track. As you see here, it's the cone. As you all know, because you're experts at this point, the cone is not the best nor the only thing you should be consulting for hurricane evacuation or just general hurricane protective action decision-making. So there's a ton of other information and National Hurricane Center products in there to help inform that decision-making in more of a probabilistic sense. And so you know what this product is. This is the graphical wind speed probabilities. And another thing to point out here that is most easily accessible in HRVAC are location-based wind speed probabilities. So not only do you get that swath that tells you what the probable or percentages are that you will experience this amount of wind in this area, and again, those are swaths, those are ranges of percentages, but you also get at this specific location, you have this chance or this percentage of experiencing tropical storm, strong tropical storm, or hurricane force winds. Depending on your use case, both of these products are very informative and can be applied. One key part of them, or one key part of this use case as well, is that if your jurisdiction is smaller, think of a locality, municipality, a county, those location-based wind speed probabilities are extremely useful and maybe potentially more useful than the graphical wind speed probabilities that gives you that swath over a specific range. That can be overlaid with wind timing information, both for most reasonable and earliest reasonable time of arrival information. So not only are you getting information graphically, visually, as to what the percentage risk is that I'll feel this specific hazard in this location, but also when will that arrive. And if you don't want that graphically and you'd rather get that in a report format, you can use HRVAC to run reports specific to wind speed and wind probabilities. This is my favorite report in HRVAC, although it's tough to choose a child, right? This is the wind timing at location report. You'll get more information on this in subsequent trainings or if you're interested, but the way you access this is to a right click on a specific location, you drop a pin, and it tells you at that location not only what the percentage of experiencing tropical storm force winds is. So if you can see in the top right, you've got the five-day total WSP, or wind speed probability, 91%, but also gives you a ton of really relevant and really important timing information. So if you go through two things, critical things to point out, you've got time of arrival and time of departure. So not only is it telling you when those winds are going to arrive, earliest reasonable, most likely deterministic, so 3 different planning factors to choose from, but also when those winds are going to depart. Again, most likely latest reasonable and deterministic, you get that range. Why that's important is there's no other place that you can access time of departure information outside of HERVAC because it is so specific to emergency management use. This is for you all as emergency managers to help coordinate and inform immediate response efforts post-impact, because you want to know, as an EM, when can you tell your people, your first responders, that it's all clear, tropical storm force winds have departed from the area, and we can start immediate response recovery, search and rescue efforts. So again, this is the only place you can get this information, and it is for you all as emergency managers to inform those immediate response efforts. Let's say you've got a larger jurisdiction and you don't care as much about a specific locality, but an area at large. This is the report for you. This is the wind timing all affected areas. This can also be refined for a specific location or a specific jurisdictional boundary. So it could be a countywide, it could be statewide, and it can also incorporate points of interest. So based off all of these things that I care about, either different counties, different states, something regionally, or points of interest, what is the wind timing associated with those specific areas? So previous report was specific to a location. This report, general to several locations, all affected areas. So we've got the hazard onset time. And the next one we're going to talk about here is the evacuation start time. And I think it's important first to talk about how evacuation start times are calculated. And so the calculation of evacuation start times essentially takes the forecast information, predominantly or mainly the arrival time of tropical storm force winds. Again, we've got two different probabilistic ways that we calculate that. It overlaps that or overlays that with clearance times developed by the hurricane evacuation study through different evacuation scenarios. And then it uses that, does a quick calculation, background math, to produce an evacuation start time. So if we can expect tropical storm force winds to arrive in 47 hours, and we know based off our hurricane evacuation study, it takes 39 hours to conduct this type of evacuation. Again, this is a specific evacuation determined by the number of zones evacuating, the different demand or the different participation rates within those evacuation zones, as well as the seasonal population, and it could be a myriad of other variables based on the jurisdiction. We know that we have 8 hours to begin the evacuation. And so we can utilize that or operationalize that in HERVAC in the evacuation scenario picker. And so this is on the bottom left of the tool in the toolbox. You bring up your evacuation scenario, and then you can pick the different variables that you would like to move through to develop that evacuation clearance time. So as we go through, we select a scenario based off the storm forecast. We expect scenario B. We expect a slow response rate, and that could be for any number of reasons, typically informed by your local knowledge and knowledge of your hurricane evacuation study. But we've seen slow response rates triggered by potentially a threat that is a risk of a threat that is understated or not necessarily does not necessarily resonate with the evacuation population. It could be because there is a large seasonal population. It could be timing based on where you are in the year. When it comes to seasonal population, worst case number of evacuees, so high seasonal population, and scope of reported time. So you're looking at the time it takes for that evacuating population to get out of the county, not relocate within the county. Based on all those variables, we've got a total evacuation clearance time of 39 hours. So we can use the evacuation scenario picker here to get to that clearance time. Then we can also run an evacuation timing report. This is a report we saw a few slides back. And essentially what HERVAC is doing is taking that scenario and taking the onset of tropical storm force winds, both earliest reasonable, you see in that third column, and most likely that you see in that fourth column, to provide, essentially doing that math, recommendations, not necessarily recommendations, but to provide information on the earliest evacuation start time and the latest evacuation start time. So again, based off that clearance time of 39 hours and based off the onset of tropical storm force winds, when is the latest that you can make an evacuation call, assuming the variables and planning assumptions are integrated into that decision. One thing that's important, and why I didn't say this is not a recommendation, is because it'd be pretty tough to make an evacuation call at 4 a.m. There would not be a lot of people out there. So the recommendation would have to be informed by your local knowledge and subject matter experts as to when the right time to call and execute that evacuation order is. So if you see an evacuation order or this information saying 4 a.m., it's probably best to think about starting the evacuation the day previous and getting that information out there even before that. if you're using your latest evacuation start time, so that's based off of the most likely onset of tropical storm force winds, less risk averse than earliest onset, you can make an informed decision to say 1 p.m. Is when HERVAC is saying I need the latest I can start this evacuation. So that then I'm going to make my evacuation call the night before to start at 8 a.m. to build in that buffer and to make sure my evacuating populace has as much information and time needed to make an informed decision. Again, this is all already within HERVAC. This is HERVAC integrating not just the current forecast, but also the hurricane evacuation study information that you and your jurisdictions developed to provide this information to use to inform your decision-making processes. Some other information that's included in HERVAC to help inform your decision-making is hurricane evacuation zones. HERVAC is currently the only place that all of the hurricane evacuation zones for hurricane or tropical cyclone prone areas live. Various states and localities have different Know Your Zone campaigns, but there is not a catch-all repository for the most up-to-date hurricane evacuation zones by county and jurisdiction. So again, HERVAC is the only place to get that information, and you can overlay that information or use that information to make informed decision-making by overlaying evacuation zones with your storm surge risk. And you can do that with both your slosh moms and slosh meows to see how your evacuation zones line up to the storm surge planning risk products that were used to inform those evacuation zones. This is probably best for people that were not intimately involved with the hurricane evacuation study process, and just a great way to keep keep yourself up to speed and up to date of the planning assumptions that you all have built and the hazard information and risk information that was used to inform the hurricane evacuation study process. Additionally, operational storm surge products can also be overlaid hurricane evacuation zones. And new for this year, and this is maybe a little bit of inside baseball or somewhat of a spoiler, there is a way, or we are rolling out a way to change the transparency between the hurricane evacuation zones and the slosh moms to make sure that you can, the storm surge products, not just the slosh moms, all storm surge products, to make sure that you can see how those two things correlate and correspond. And so right now we're looking at a mom, as you can see on the right, this is our Storm Surge Explorer, and you can see the category 4 is selected for this specific area in North Carolina. If we go to the meows in the Storm Surge Explorer, you can see that you can select and turn on various other characteristics that define the meow. So not only do we see storm category on the top, category 4, you also have the ability to overlay multiple directions of meows. So you can see they've got north by northwest, west, and north by northeast turned on, and that'll essentially give you the highest meow for each of those characteristics. And at the bottom, you can see the forward speed of 15 miles an hour is selected. So that's all to say there's a lot of ways that you can access and incorporate this information in HERVAC. HERVAC is the only place where slosh moms and meows are readily accessible, especially the meows and especially in this format. And one thing that I will point out on the bottom right, you can see export data. And in HERVAC, you can pull out these storm surge risk products, planning risk products for additional use and incorporation in other geospatial tools that you have. So you've got your planning products, and then now you've got your operational products. These are produced through the NHC advisory package. This is the peak storm surge graphic. So again, this is that KML or that graphic that is developed by the National Hurricane Center in advisories, giving the forecast for storm surge inundation in a specific area. And then here is your P-surge or potential storm surge inundation map, potential storm surge flooding map, and this also can be integrated and overlaid with the evacuation zones in HERVAC. And again, this year we're making it a bit easier, allowing you to overlay and change the transparency of the two so you can see how in fact they correspond. So that's all to say, you've got your evacuation zones, you've got your planning storm surge risk products, and you also have your operational storm surge risk products in HERVAC that you can integrate together to make informed protective action decisions. So again, HERVAC is free for you to use if you're a government emergency manager. We do have very robust planning and support resources for HERVAC, and I'll walk through that here very briefly at the end of the session. And feel free to reach out if you have any questions, concerns, or needs. I will flag at this point, we do have a HERVAC webinar series forthcoming. If you need the crash course for all things HERVAC, how you can apply different tools, functionalities, data sets for planning and operations, this is the course for you. It's going to be May 19th through 21st. It's going to be offered 2 to 4 p.m. daily Eastern time, and you can register for that course on hervac.com, and I'll show you where in a second. All right. The next question the next questions that emergency managers or we as emergency managers ask ourselves are within how do we understand all the things and assumptions that are baked into the forecast? What is the confidence and contingency based off the forecast products? What is the forecast and how does it relate to evacuation timing, hurricane evacuation study data? And is there a way that we can get additional information or a briefing based off of the information we're seeing, or just to fill in our knowledge gaps or ask informed questions too? And the answer to those questions there are, and it's the Hurricane Liaison Team. And so with that, I'll turn it over to Michael Spagnolo to brief out the HLT.
Hey, thanks, Zane. Yeah, we just want to take a quick moment to highlight kind of the FEMA Hurricane Center partnership. And for those of you, especially that are at the state level, if you may have been very familiar and interacted with the HLT, which began in the 1990s, and it was formally codified after the 1995 season by the Florida governor at that time. And the state director wrote a letter to FEMA and the Hurricane Center and saying, hey, we need more support. We need kind of someone to help bridge between the forecasters on the ops floor making the forecast and us making the evacuation decisions in the field. Obviously, the forecasters are very busy making a forecast, and the decision makers are very busy making their evacuation decisions. So they wanted to help have a team that can work to help bridge that gap between that, and thus the idea of the HLT or the Hurricane Liaison Team was formed, and then full-time positions from FEMA side were then brought into the building here in Miami at NHC, and we are housed here year-round, supporting both the programmatic side of the hurricane program with trainings and outreach and working on new updates, and then operationally during hurricane season. So the mission of the HLT is to improve the nation's capability to respond to hurricanes through the rapid exchange of critical information, again, serving as that bridge between the decision makers and the forecasters. The flow of information in the HLT is considered to be a two-way street. While, of course, you typically would think that a state emergency manager would want to get information from the forecasters, but the Hurricane Center is also receiving information about the decisions being made, especially in the storm surge unit, having awareness of which evacuation decisions, which orders have been announced. Are they kind of matching up with expectations based on the surge modeling, the P-surge that the surge unit folks are looking at? So the HLT is not just Matthew and I down here. We have regional components, and for those of you at the state level, you're probably familiar with your regional hurricane program manager. So each of these FEMA regions has a hurricane program manager that deploys down to the National Hurricane Center when there's a threat to their region to help be that point of contact with their states. And then they are also the ones who are working on the hurricane evacuation studies in their jurisdiction. And they are the experts on their regions evacuation studies and their states evacuation studies and their locals. So they're who Matthew and I bring down because, hey, when we've got a storm moving towards the Texas or Louisiana coastline, or whether it be Florida, we bring our counterparts in that know those states well, have their connections, and are really the experts in those evacuation studies. So there's an example of a briefing going on in the HLT office. That's Dr. Michael Brennan of the Hurricane Center providing a briefing to FEMA headquarters in the regions and the states. Again, for those of you at the state level, probably familiar with the 1230 interagency VTCs that go on when there's a significant hurricane threat. So we're preparing briefings for those. And even down at the local level, some of you may have been on a state level call at which the Hurricane Center is providing a briefing. So as I said, it's a two-way flow of information, not just in the formal briefings where the Hurricane Center is brought on to provide that additional context with the local offices to state and local partners, but also kind of those informal conversations having on the side, especially between the hurricane program managers who are maybe out on the floor with the storm surge unit, and they're helping talk to states and counties that are making evacuation decisions. Because again, all of that storm surge modeling and forecast information is coming out of this building. And then that's what's being relayed out to the states, locals, and the rest of the Weather Service. So with that, Zane, back to you for your review.
All right. Thank you, Michael. I appreciate that. And thank you, everybody else. With that, that brings us to the conclusion of this course. And in Unit 4 and in this course, so in Unit 4 specifically, we talked about the hurricane evacuation studies, how the data and information therein can be used to inform your planning processes and your informed decision making during planning and operations. We've talked about clearance times and their use. We've identified the capabilities in HRVAC and how all this lives together in HRVAC and is integrated for ease of use and informed decision-making at the emergency management level. And then also what additional services within the National Hurricane Program collectively and interagency partners you can pull on to help inform your decision-making in all sides of the emergency management process and cycle. And so with that, I'd like to thank you all for your time through this course. Again, we covered not only Unit 4, how to make informed decisions, but also all the different pieces of that process, understanding the uncertainty in the products produced by the Weather Service and the Hurricane Center, and how they integrate probabilistic approaches to make sure that you have the information you need to make informed decisions. We've talked about the baseline of those products and what is available and when it's available. And we started this course talking about hurricane climatology and hurricane meteorology, or excuse me, tropical cyclone meteorology, and all the associated hazards and risks that are turned to that. So at the end of this, I just want to say thank you all for coming along with us on this ride over the last 2 days. I want to say a huge thank you to the support staff, both answering questions as well as providing captioning and American Sign Language support. Thank you so much for your service and support to this enterprise. And thank you to the instructors and everyone that helps make this course possible behind the scenes and during the actual execution. With that, I'll turn it over to Michael Spagnolo. Is there any additional questions in the chat that we would be good to talk about before we wrap up here?
No, I think we had a few questions about HRVAC accounts and potential HRVAC trainings that are upcoming and other places to get resources if you want to reiterate where they can get more information on training for HRVAC.
Yeah, fantastic. I'll get there. We'll get there, and I'll provide just a quick overview and demo of what's available right now, and answer questions that come up as to future trainings as well. So we talked about the course review. First, we talked about the hurricane life cycle, climatology, and associated hazards. Next, it's what products and services are available to you and when they're available to you and how you can use those to inform your decision-making processes. We've talked about uncertainty in NHC forecasts and forecast products and how they should be considered, as well as how products and services are have uncertainty baked in to help inform your decision-making processes. Finally, what is available to you as emergency managers to make those informed decisions, both in the planning, preparedness, operations, and execution around hurricane threats. Lastly, just another plug for NDEMU registration, or formerly known as EMI registration. If you'd like to get a certificate, if you'd like to get course credit or CEUs for this course, you have to fill out you have to register for the course on NDEMU's or EMI's website. And as you register, after you register for that course, you will get an evaluation form. To get credit for this course, you have to have attend it, be registered, and then fill out this form and send it back to our NDEMU counterparts, and they will walk you through the rest of that process. If you have questions, please feel free to reach out to nhp@fema.dhs.gov, and if someone can drop that in the comments, please do. And I want to thank Jim Blazes and the NDEMU team for supporting all the coordination as well as back-end finalization of this effort with NDEMU and the rest of the team. So again, reach out if you have questions. There's no requirement to fill out these forms if you do not want to do that or don't care about credit. If you'd like credit, if you'd like CEUs, please go out and do that and let us know if you've got questions along the way. One additional thing is when I end this webinar, post my HRVAC demo and post any outstanding questions, there will be a quick survey sent to you all. If you're able and if you feel so inclined, please fill that out. Let us know how we did. Let us know how we can improve this course. This is the first virtual offering of this course that we've offered since COVID. So we want to continue to offer forums like this going forward. We just want to make sure that they are useful and they are right-sized to you all, the stakeholders, and you all, the participants, and we're not giving death by PowerPoint over 2 days here. So thank you for that. With that, I'm going to stop my share, and then we're going to go to HRVAC. So 1 second as you bear with me along this ride. All right. And can I just get confirmation from someone online that you are seeing HRVAC and it looks good?
Yeah, it's still loading at the moment for me. There you go. Can see HRVAC. Looks good.
All right. Sounds good. Fantastic. So this is what, if you typed in www.hrvac.com on your search bar up here, this is what you'd see. This is the HRVAC landing page. There's a few things that I'm going to point out here that help you get to help you get situated with this site. Right here, you get to see the great stats of HRVAC and just how impressive this platform is. This has been a historic tool and application within the EM community around for over 37 years. It's helped with over 268 storms and it has over 30,000 users. And so it is well known and versed within the EM community. Please let us know if you've got questions or comments related to it. And if you are just now getting started with HRVAC, a great place to start is in the Learning Resources tab up here at the top. As you click in there, you get a quick guide to HRVAC. You've got a quick reference guide that you can download and use as a helpful tool moving forward. And then you've got the HRVAC workspace handout. I'm just going to click on that now. And this is essentially a down and dirty of everything you need to know about the HRVAC tool, the associated map layers and functionalities. And I keep this on the side of my desk at all times because not only does it help me stay informed about HRVAC, but it helps me to communicate HRVAC to other people. And so it's easier to point at this, give them a resource and say, go forth and conquer than sometimes talking people through a tool itself. So highly recommend printing this out, having this on hand. If you're a new user or experienced user, it's a very, very useful device for understanding HRVAC, everything that's encapsulated in it, as well as what types of functionalities you can get to based off of different sections of the tool. Again, that was in Learning Resources, and then right here, the Download Workspace handout. Additionally, you've got some information about HRVAC, kind of your just-in-time quick start training. These are YouTube videos that can also be found on HRVAC's YouTube channel, a great place to start. Next, we've got recordings from past webinar series, and this is a great time to talk about this year's webinar series, which you can sign up for. Sorry about that. The training events. So Learning Resources, training events, and you've got the 2025 HRVAC webinar series sign up page. Go through, register for days 1 through 4. Again, this is the best way to get trained up on HRVAC right before the hurricane season. If you can't go through all 4 days, that's just fine. These will all be recorded and available after the fact on HRVAC.com and the YouTube channel. Additionally, each day will be 2 hours long. It'll go through a specific subject area within HRVAC and will be briefed out or introduced by experts from the National Hurricane Program and the National Weather Service to ensure that you're not only understanding the HRVAC as a tool, but understanding the good information that HRVAC is integrating and ingesting from the Weather Service as well. So highly, highly recommend that you sign up for these if you have not, or if you're new to HRVAC, or if you just want to knock the dust off before hurricane season. You can attend them or can attend one of the days. That's just fine. They will be recorded and available to you all after the fact. All right, one other thing to point out, in support services, we do have robust program support. So you ever have a question or comment related to HRVAC, we've got support at HRVAC.com and a FAQ page that is kept up to date. Highly recommend reaching out to them if you've got questions or comments, or you can reach out to your National Hurricane Program representative, regional hurricane program managers, the program manager, myself, or hurricane liaison team if you've got questions. And the support is offered 24/7 during hurricane season. So if something goes down, please flag it because you might be the first person to see a bug in the system, and that helps us make sure that it is up and running for everybody. All right, so if you're new to HRVAC, the way you get a HRVAC account is in sign up. You just go through, click on this, you provide this information, and again, it is free to use for any public-facing emergency managers or emergency managers connected to public institutions. So if you've got a .gov, if it clearly indicates that you are public-facing EM or associated with the public organization, your user request should be expedited. But if you are tangentially coordinated or connected to a public emergency management organization, just let us know right here in the job title and role in emergency management. We might ask you to provide a reference or to have someone provide a referral. But if you are clearly associated with a public-facing emergency management organization, typically we can get you access as well. All right, so this is if you don't have a HRVAC account. If you do have a HRVAC account, you just go to log in. And I've already logged in, so it's just going to pop me into the tool. This is the HRVAC interface. This should look familiar to you. You just saw some static slides of it. Just very quickly, a lay down of the workspace itself, because if you want full training, it is best to attend the webinar series or look at the other resources. But up here in the top left, you've got your map layers. This first tab is storms, where you can see active storms, as well as historic and archived storms and simulated storms or exercise storms. So that's all to say, it goes back to 2005. There's a ton of good information in here. And if you wanted to go in and see or train off archive storms, for example, we'll use Adalia, that information is here as well. Additional information that you get in this top left is the conditions tab. This is information about current weather conditions, not tied to what we're currently looking at here, which is the archived track or advisory packages from Adalia, but rather what we currently are seeing. For example, we've got, why don't we turn on the ERO? And so that shows you overlays on the map, current weather information, as well as current products produced by the national centers, not just the Hurricane Center, but also the Weather Prediction Center, National Water Center, and so on. Lastly, in the resources tab here, you have additional associated resources. These are layers that you can click on and off that could be informative or helpful in your in your workplace organization. But two things I'm going to identify here: hurricane evacuation zones. And so this is where you turn on essentially all the evacuation zones within the US. Again, the only place you can get this information publicly available. And so just to give some examples here. So we've got Alabama, this is Florida. And so that information is here in evacuation zones. And then right here in the library, you have hurricane evacuation studies. So library, hurricane evacuation documents, and you go through and you have different HESs, hurricane evacuation documents, tied to places that studies have been completed. This is the only place they're publicly available, quote unquote, publicly available. Your jurisdiction should have a copy of this. If you need a copy of it, please let us know. If not, you can get them in HRVAC and you can download all this information as well. Next, we've got the toolbox here. And essentially, this is your way to interact. Excuse me. This is your way to interact with additional functionalities within HRVAC. I'm not going to do a deep dive, just a general workspace overview, but some key ones to note is you've got the reports tab, and this is where you can get different reports, including wind timing and evacuation reports. You've got your storm surge tab right here, which is where you get that storm surge explorer or slosh explorer to get your moms and meows. Again, they can be exported. Additionally, we've got the hindcast information here as well. You've got your evacuation timing tab, which is where you can find that evacuation scenario picker, which will give you your evacuation clearance times. So if we're just going to use this one in Florida as an example, and then you've got different jurisdictions, state and county here. And then you've got additional training. And this is where I probably should have highlighted this first and given this as identified this as a first spot for you to stop. But essentially in the training tab here, you can utilize and you can access different training modules, within the application of HRVAC. So we've got things like introduction to HRVAC. We've got customizing the workspace, how you fine tune the workspace to suit your needs, and other additional information or functionalities within HRVAC. So good training resources you have. You've got the videos, you've got the static documents such as the overview and the workspace overview. These are in-app modules that will zoom you around the app and identify different ways to familiarize yourself and functionalities within HRVAC. So highly recommend you start there. These are your storm tools right here. So these are different ways to interact with forecasts within the National Hurricane forecasts produced by the National Hurricane Center. And sorry, this is very much by the seat of my pants. So this is with Adalia here. And so essentially you've got the different forecast products that are produced by the Hurricane Center that you can interact with within HRVAC. And you saw all this in the slide. I'm just showing that you can go in and click them on, click them off. Again, these are all tied to current forecasts. And then at the bottom here, you've got ways that you can interact with or fine tune the ways that you're interacting with or seeing this information on HRVAC. Track and swath options, essentially what this looks like as it's displayed. And these are quick layers. So essentially changing and morphing the different layers that are available to you within HRVAC. The last thing to point out here is on the right, you've got your utilities and user preferences. You can see my clicker, I'm sure if you can. Utilities help you customize the workspace and interact with the workspace in different ways, essentially tied to different functions of the back-end map or background map and geospatial platform, not necessarily the forecast. These are things like panning over. These are things like setting your map extent, things like trying to find different distances depending on distances and areas using this tool. And then on the bottom right, you've got user preferences, and this is essentially how you customize the workspace to your needs. Again, this is not a HRVAC training. That is the 30,000 foot overview, maybe 100,000 foot overview of everything you can do in HRVAC and where it lives. I would highly recommend that you go in, familiarize yourself with the tool, either via the training modules or different training resources, or just say, I'm going to hang out and attend the HRVAC webinar series in May. That is the best place to get all the information on HRVAC. You'll have an introduction to the tool, an overview of the workspace, as well as additional training resources that you can consult in hurricane season. But the big takeaway is HRVAC is free for you to use if you're a public sector emergency manager, and it is the one place to integrate current storm forecast information with hurricane evacuation study information to help inform decision making.